Well, 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 it's another beautiful night. It's October 6th, 2020. This is Mark D'Antonio with Sky Tour Livestream. I want to just say hello to everybody out there and see how everyone is doing. I have with me my ever-present astronomical cohort in crime, Daryl Mason. Hey, Daryl, how are you?
Hi, Mark. I'm good. How are you? Hello, everybody.
Oh, I'm fine as well. It was sort of a bad day work-wise because, many of you know I have a company which makes visual effects miniatures, and today was a bad day in the miniature world. I couldn't make any real progress, so I really felt like it was a tough day. But this is going to help me. Yes, indeed. I really enjoy this very much. So here we are. Hello, everybody. And this is not our live screen here. This is actually just our view. It's our captain's screen, isn't it? It's the one that we actually get to see. We actually get to see what's going on here. And I'm trying to locate what's happening here. All right, well, hold on. Here we go. Let's go over and grab a hold of our other screens here. I'm in the wrong place, that's why. Here we go. Okay. So yes, we are live tonight, and it's a good thing because it's fun being live. I really enjoy it, and there's our observatory view, which is right here. You can see the lower right box down there on the far right. It's a live view of the telescope in the dome. This is up in the upper right there. This is our camera view. So this is the camera control system. This is me. Hey guys. Okay, and I will often come out and point to things like, here, this is our, this tells you what mode we're in with the camera. This gives you the speed the camera's at right now. We're at 16,000 ISO, which is a camera sensitivity setting, and we're doing a 30-second shot. That was this last shot we just took. All right, then up here, all right, what you'll see right above me, above my head here, okay, this is our telescope control system right here. These are the telescope controls. These are the telescope computer controls. This is the camera focus for the telescope. And that box right above me, okay, that just vanished. I'll bring it back here. There you are. Okay, that box right there, right here, you can see this is actually our filter wheel. All right, we have a filter, set of filters that we look at our sky through. And these filters are very helpful to us. So right now we're on what's called narrowband 2. You can see that little 2 right after the word narrowband there, right? We have several others. We actually have, besides narrowband 2, we have an even fainter filter. It looks like the stars are fainter, but it's bringing in specific data. Okay, I've talked about this many times with you guys, but just to keep it the same, so you remember. We have our full spectrum of colors that comes from the stars, right? Red, orange, green, blue, yellow. I'm sorry, red, orange, yellow, blue, green, indigo, and violet. Well, of those colors, we want to take narrow slices through that spectrum and just send those through the spectrum. Those are at positions in the spectrum that have all the vital information we want to see, like nebula clouds and things like that. So when we look at the regular screen with our eyes like this, we see what looks like very little data, but the camera sees a lot more. Now, if we go ahead to narrowband 2, you'll notice that the stars are a little brighter, and we can actually pick up an additional star or two, like this one here is now showing up, and there's a couple more showing up. Okay, those are also narrowband. That's also a narrowband filter, but those are slightly wider cuts through the major spectrum. Slightly wider, so I call it the wider narrowband, or we'll call it narrowband 2. We also have a spectral system, which allows us to see the spectrum of the stars, like that right there up there. You see the red, orange, yellow, green, blue, indigo, and violet colors. And we have a system here that we're installing on the next scope that we're putting in after we do Arizona. And that scope will have the ability to look specifically at the spectra in an extremely detailed way. So we can actually see what makes up a nebula, what kinds of chemistry is going on in there. In other words, what are nebulae made of? What's going on? Anything cool to see, we can catch it. We can look at the clouds of Jupiter and see what it's made of. I mean, stuff like that is pretty cool. I mean, that's sort of that's real science, but you know what? I won't bore you with that. We'll just explore it for fun on days, and we'll be able to do alternate things. We'll be able to do that or something else all in the same night. We're not going to be just specifically that. Okay, then that's filter 3. Filter 4 is black, because sometimes we need to capture just darkness to help figure out how the camera's doing, so we can calibrate the camera's noise that it generates. And filter 5 is just a pass-through. It's just an open hole. That's why this is the one where you see the most stars. Okay? Then that's...
I like the Jumbo Shrimp channel.
I guess so. The Jumbo Shrimp channel. You never know what's going to arrive. Is it a little jumbo or a big shrimp, right? George Carlin, my favorite comedian. So then we scroll the wheel again, and we're back to narrowband 1. We tend to focus on narrowband 2 for most of our photography needs. And tonight, what we're looking at will vary, but we're looking at a few things. And we're going to slow this down a little bit, bring us back slowly. This object here that we're looking at is something called the elephant's trunk. And I recognize this little cluster of stars that you can see right here. There's actually a couple of little stars there. There's actually 3 stars in there that are kind of tough to see. But the elephant's trunk is actually right about here. It's sitting right here. And it's a long, dark nebula. And I figured before the moon rises, we should try and see if we can image it just for fun, you know. So over here on the right, you'll notice that our camera is set to the ISO, or the speed, of 16,000, and we have a time of 30 seconds on there. Let's go up to the next one up and say 1 minute. This will be a test shot just to see what happens. So in that 1 minute, I can do a couple things. I can show you what we have seen before. Okay, this is our view that we looked at before. Not we, but me. Okay, this is the elephant's trunk region just a few moments ago. I'm going to just move it over a little. That's what I want to do. Okay, and the elephant's trunk region is right here. You can see these stars I was telling you about, and the elephant's trunk is right over here. You can't really see it too well because of the fact that I'm in the way, number one. But once I get out of the way, this was only a few second exposure. So if I'm doing now a 1 minute exposure, and if it comes out good, it'll look a little different. You'll actually see the dark nebula that's there. The other night I actually did multiple photos of this region, and we actually looked at it, and you could see the elephant's trunk very, very nicely. So we'll see what happens. I want to say hello to Marianne Robb, who is very, very important to everything. Carmelita is here. Tara is here. I know that Daryl's here because I'm talking to him, right? Daisy and Zoe are here. Weird Guy's here. How you doing? And to all the rest of you, Justin, and actually Tara was first, I believe, and first to write, and Justin was the second person in. You guys are awesome, man. And Vera Lucia Campos, hello. How are you? I hope you have a good night tonight with us. We were here to help you and to teach you astronomy if you'd like to learn about it, because I'm one of those crazy astronomers. This is what we look like. And I can't help it. I can't help but get excited about looking at the night sky, especially look at the stars. You know, it's just beautiful. Brandy's here. Hello. And it's so good for you to be here. And of course, ever-present Keith from P&K Space Imaging, probably the only moon and planetary viewing site you'll ever need. P&K Space Imaging. Make sure you subscribe to that on YouTube. And if you haven't subscribed to Sky Tour Livestream, which is this, we are the live deep sky, and I think you guys should subscribe to that too. It's free, man. Hey, good things in life are free. Hi there, Rockstar. How are you? Anahata77. Nice to see you too. Yeah, and look at that. You can clearly see. Okay, I'll just show you right here. Look at this right here. You see that? Look at that beautiful line right there. You can see that line of nebula right there. That is the Elephant's Trunk Nebula. Wow, look at that thing. I have to say that. I mean, without the moon in the sky, it looks beautiful. Now, this is with filter narrowband 2, so it's the wider slices, wider but still slices through the spectrum. So why don't we take another shot real quick. I'll just go grab, let's go back to this actually. All right, and I'm going to just show you what I'm doing so that's not hidden. And I'm going to drop us back to the other filter, which is narrowband number 1. It's the most narrow filter. And I'm going to take us from 16,000 up to 25,600. I found that you have to increase the sensitivity by 2 times or increase the exposure by 2 times. It's called stop, by 2 stops to get this. Now, you see that I drink water a lot. And it's because, I'll take this picture now. Over the last couple months, I've dropped over 20 pounds. And all I've done is I walk the dog every day. Okay, I take him up to a field. We go around a field. It's a big field. About a mile I go with the dog each day, but that's not really a whole lot. But then what really happened, the best part is that I drink water all day long until dinner time, and I eat a regular meal. So I eat 1 meal a day. And the first day or two, I thought, I'll never make this. And it's not a diet, it's a lifestyle change. And all that water helps the kidneys, and all the energy you gain back, and you do gain energy back from this is just, it comes back to you in droves, because having that energy is just so much better than not having energy at all, let me tell you. And I mean, I wasn't fat, I wasn't heavy, but I mean, I was heavier than I needed to be. So as of now, I'm just about a pound under my high school weight. And that's something that I never thought I'd be able to say. And it happened all by itself. And this is not a commercial or an ad for anything. I'm just telling you, it works very well. You should give it a shot. Okay, water all day until night, and then you eat a regular meal. To maintain, you can have a small breakfast. I actually will eat now that I've lost the weight I want. I'll have a piece of toast with peanut butter on it in the morning. And then around lunch or noon, or 1 or 2, I'll have these little breakfast crackers. I'll have them just for a quick thing for lunch. And then I just keep drinking water. I'm telling you, it works. Hey there, Carol.
I've tried that.
Huh?
I've tried that. I can't do it. I get rubber-legged if I don't eat something in the morning.
Yeah. Well, you could also eat a big breakfast and then eat minimal dinner. Do it from the opposite side.
That's like the old saying, eat like a king at breakfast, a prince at lunch, and a pauper at dinner.
I guess.
Hello, Carol. If it's confession time, I'm not going to say how much weight I've lost, but it's a whole lot.
I bet.
I'd like to, end of ski season 1984, I weighed 164 pounds.
Wow.
and I would like to get back to that. Actually, I'm right about 200 right now,
That's
so I've got about 35 to go, but I have lost a ton of weight. Maybe I'll tell you in private.
no, it's okay. You should be proud of it. You should crow to the world with that. I mean, you should be very proud of that. Look at this, guys. This narrowband filter, you can see very clearly. You can see the elephant's trunk right there, very, very obviously. But keep in mind that the photos are taken for the camera; they're not taken for the human eye. So, really, the best photos will be the ones like this, where you can actually see a little hints of this reddish, diffuse nebula behind this dark nebula, stuff like that. So. This is the narrowband 2 filter. Okay, this is narrowband 1, the tightest shot. All this noise, well, I can get rid of some of that right now. Ready? Here, so I get rid of some of that noise for you. But for the faint detail, it tends to this noise removal technique will also remove some of the actual nebula that you're supposed to see, leaving the noise in. You can actually see the nebula actually better. And I only process these guys. I only process the very noisiest ones because I can remove all that noise. And the images do come out quite nice. So, hey, that's cool. And as Daryl and I were talking before the stream started, I wanted to let you know that Mars is approaching the closest approach to the Earth. And Daryl, you said the exact date was when?
The exact date is closest is today. The moment of opposition happens a week from today on the 13th.
Okay.
That's when the Mars, the Earth, and Sun are in a straight line. And generally speaking, you'd say that's when it's closest, but because of the elliptical nature of Mars' orbit and our orbit, it's actually closest today.
Yeah. Well, today when we look at it, we should see, if we're going to see detail on the Martian surface, we're going to see it tonight.
I sure hope so.
Yeah. It's actually a fairly reasonably good night out there. Still a little bit of moisture in the air, but, we'll deal. We'll deal.
It's hazy here still. I guess the smoke from the fires up north of here are still hitting us pretty bad.
Yeah.
Otherwise, wonderful day today. It's been up in the low 80s here lately in the daytime, just down in the 40s at night.
Wow. Hi, Tim. How are you? Marianne asks a really good question. She says there's a star formation just above the elephant's trunk. It's pretty amazing. She says a circle. Is there a name for that? Well, let's go back and see what she's talking about, shall we? I think she's talking about this. Let's go to this other guy here. I think she's talking about this right here. Because that is above the elephant's trunk. That's actually something that, Marianne, that's actually a pattern of stars that has no particular name as far as I know. But it's actually something that does occur quite regularly. You can see patterns in the sky like that. And it looks like a pretty good circle, but it looks like a C more than a C rather than a circle. Your mind is turning it into a circle. Your mind is making it into a circle, but it's not really a circle. So yes, that pattern is actually just a random pattern. When you have so many dots, sometimes patterns jump out at you. And they just seem like they shouldn't be there. Like the Belt of Orion, 3 stars in a row. Bing, wow, look at that. How could that possibly be? These 3 bright stars all in a row. Well, it just so happens that they are, because those 3 stars are all at different distances from us. They're not at the same distance. So it just so happens to be that way. But the sky is full of these types of things right here, this dark nebula. Now, just so you guys know, if you've just joined us, hey Genghis, welcome. If you just joined us and haven't been here before, I just want to let you know, the Arizona Observatory is underway. We have a few hiccups here and there, but we're making sure that it all works out smoothly. And we are hoping to have first light I wanted it to be, this week, but of course I couldn't do it because the building has to get, designed, or not designed, it's already designed, but built properly, and we're not there yet. I'll tell you honestly what happened. We had a crew that was going to come out and build the building. The night before they came out, they called me and said, okay, we're coming out to build your building. Now, you guys have heard the design. We're going to have a building, and it's going to have a roof on it, and the roof is going to roll right off the building onto posts into the ground, and those posts are going to be taking up the roof, okay, and the weight of the roof. Well, on the contract, it says the roof is to be separate. And I said to the guy, okay, so you're going to make a roof separate? Yes, we are. Okay, good. So you'll build the 4 walls, and then so maybe you can just tack the roof on temporarily until I can get the people to come out to actually put the motorized system on to roll the roof off the building. And he says, what do you mean? I went, well, we have to take the roof has to be able to come off the building. And he said, well, we can't do that. And I said, you just saw in the contract the roof has to be separate and not attached to the building. Yes. So somehow you think that means you are going to attach it to the building? He just couldn't get it. So we went back and forth for about 10 minutes, maybe 15. And then I said to him, you know what? Maybe you're not the right people to build this building after all. And we fired him. And so we went to someone else, and that someone else got all these great ideas, good friend actually, knows what he's doing. And then he had a issue with a former legal claim he had come up where he had to pay attention to it in court. And we lost him as a contractor. So now we're searching and searching more. And Marianne is doing all that legwork. I wish I could say I was doing it, but she's doing it. It comes out... she says, I have 3 contractors I'm looking into. Fantastic, Marianne. Mwah. Beautiful. I mean, we have to get this thing built, and no one knows that more than she does. She's a mad dog. Don't ever get her mad. And don't ever tell her you're going to do something and then not do it. So she's the perfect person to have doing this, I'm telling you. Don't tell her I said this, but she's really quite something. Shh, don't tell her. Oh, wait. Oh, she probably heard that. Anyway, we're okay. We're happy about it, and all good things come to those who plan and try to deviously overthrow the powers that be. Oh, no, wait. That's something else. So anyway, that's the story, and we're gonna see this come to first light, I think, fairly quickly. We have a much simpler design, much simpler to do, and it's probably just 4 days of work for someone who wants to build out in the desert. And the temperature's not 120 degrees. It's actually going to be a relatively mild 95 in dryness. So it really will feel like 80. Anyway, so there's Sky Tour West update. And Marianne also showed me a license plate she got, STLSW, for a Sky Tour Livestream West that she purchased. And I told her that for all her help, there is no one better deserving of that license plate than her, and she should put it on her vehicle. So she will be the official face of the Sky Tour Livestream West construction efforts, and I think that's she's earned that place. She's really, really good. So there, and there's a lot of people that are helping me along the way as well, and they all will get something in return, no doubt. So we're working on it, and I'm pretty pleased that these folks are around, because without them, this wouldn't have happened. So hey, Tim F, how you doing? Lynch Hub, Kyle Lynch is here. Kyle, recent transplant to Florida, land of the sandbar, and the mosquito, big big mosquitoes. I mean, you know, Brunzinger, big giant mosquitoes. You know, Isabella Melamed, how are you? So yeah, okay, so let's go back and see where we are here. Okay, let's check out a couple more objects here. So we're here at the elephant's trunk, and we can... I'm trying to find a way to get us to another... Yes. Yeah, that's kind of low, though. Let me, I'm just looking for a few things here. I know you people are seeing Andromeda Galaxy. I know. I want to show you the Andromeda Galaxy. But I want to wait a little bit longer for the Andromeda Galaxy. Actually, it's 50 degrees up, so we should be able to see it, but I'm wondering whether I'll have to move the dome. And I don't want to do that. So what I'm going to do first is I'm going to see if we can look at the Heart Nebula here. I mean, we are pretty lined up with it here, so let's see if we can do that. Okay. Here we go. Let's find out. Alright, so we're heading down to what could be the Heart Nebula as long as the dome isn't in the way. I should probably make sure. Okay, it's not in the way. How do I know? Because this. You can see our observatory cam down here. That's the star that's being used as our guide point. And when it goes away, it means that it's heading to the nebula directly. And you see nothing, I know. But you know what I could do, just to help you see what's going on, is I could just go back one level here, and then you actually see the stars. Okay. Now, technically, we should be on the heart. My scope icon is not aligned. We're looking for this guy right here. Okay, and that is the Running Dog Nebula. I've never heard of it said that way, but that's Stellarium for you. This is a free product you can download if you want. Stellarium will give you the night sky at a glance. It's beautiful, and it will control your telescope for you as well if you wish. So let's see if the Heart Nebula is in here. I seem to remember these stars. So first things first, let's go back to our filter. Let's go and bring up not the pass through and not narrowband 1. Let's do narrowband 2. Okay. And let's just do a quick shot at 30 seconds here. When I get to an object, it takes about, I would say 11 seconds plus or minus half a second to lock on to a guide star, because this telescope is auto-guiding as well. So that 11 seconds, of course, has come and gone, so I figured to take the shot at 30 seconds, see what we get. We should see some nebulous detail in the shot. Daryl, you remember the Heart Nebula? We've looked at it before.
Oh, yeah.
Yep.
Heart and soul right next to each other.
Yeah, and we're seeing it right now. Here, let me show you what else we're seeing. Okay. So here is the cluster at the heart of the Heart Nebula. Here is the nebula. You can see it there. There's more nebulous detail out here. And, of course, we have an interloper. That right there. This is your friendly neighborhood Spider-Man. No, not. It's a satellite that's zipping through our field. Let's see if you guys have picked up on this. Which way will that be going? If I take another picture right now, will it be out more over here? Or will it not be in the shot because it's gone that way? I wonder if you guys know that answer. Let's go take the shot and see right now. Gotta do it fairly quick. It's sort of a giveaway, I think. I do not know the name of this particular satellite. We'd have to look up in the ephemerides to see which satellite that is. I actually have an application. Yeah, go look it up. You can look at heavensabove.com if you want. Kyle Lynch Hub. So I took that shot a little longer. Probably going to be... should be here. Okay, it looks like it went too long and it went out of the shot.
Too far north to be geosynchronous.
Yeah. It wouldn't be geosynchronous anyway because it's too bright. Geosynchronous satellites are what we call a magnitude of brightness of right around between 14 and 17. There's no geosynchronous satellites that are very, very bright. And in 30 seconds, the trail would only be about the length of that arrow, maybe just a little longer, slightly longer. So it's out here down on the right. They tend to go toward the east, and east is this way. It would take an awful lot of knowledge on your part to know that. And let me just make sure I'm not lying to you. Let's go to the Heart Nebula. All right. There's the cluster that we're looking at. All right, and yeah, that was correct. Okay. Just making sure. Hello, Trish D. Hey, D. Smith. And Carolina Sky. What's going on? How are you? So good to see you guys here. Let me bring this up a little bit further into the field, shall we? Well, we're going to bring it up a little further into the field. Okay. Now we have to wait 11 seconds again. Actually, we're going to go a minute on this one after this. Well, first I'll get a positional view. We should be okay. Okay. And now I'll just do 25 seconds just to get a good view. Let's see if we got it. Yeah. Hey, Donald Kunzer, how you doing? Ah, dead center. That's really nice. There we go. Yeah, that was only, like I said, only a 25-second shot just to make sure I got it right placed. And now what we can do is take our imaging and drop it up now to not 30 seconds, but we'll go to a full minute at 25,600 ISO or sensitivity, and we'll see what that does. I know what that's going to do. Don't tell anybody. Here we go. So the Heart Nebula is a really interesting place. You see this cluster of stars in here. This cluster, and I'm going to go to the shot we took just before. Okay, this is the one that had the satellite in it. This cluster here, born in this location amidst lots of hydrogen gas, the universe's most copious element. This cluster was formed at some point, some millions of years ago. These stars aren't billions of years old. They're only a few hundreds of millions of years old at most. And they are a young cluster, and they have a copious amount of ultraviolet light. And that ultraviolet light will spew outward from all these stars and hit the remaining hydrogen gas and do two things. One, it's going to excite the hydrogen atoms so that they actually glow, and they glow red. It's a characteristic color. And that's the first thing they do. The second thing that they're going to do is their wind is going to push this gas further away. So it's almost like they're born in a room and then they push all the furniture out. And that's what they do. And that's why when we see many clusters in the night sky, there's no gas like this around them, because they're slightly older. They've already pushed and dissipated all that gas away from them. That's kind of cool. It's the way the universe works. And that gas being pushed away will eventually be harvested by maybe another location where the gas impinges on a cloud, slows down, compresses, and that might start a gravitational collapse that might give rise to another star or stars. And this process has happened more times than the number system would even be logically capable of expressing. That's why everywhere you look in the night sky, everywhere in here you see stars. Everywhere you look in the night sky, point your telescope somewhere in the sky, take a deep sky shot, you're going to see stars filling the view. There's very few places, Daryl knows of at least one, where there are not very many objects in the night sky. We call those voids, and it may not necessarily be stars. Okay, now that was a 1 minute shot, and it has this look like it was got a light problem. That means the moon, what time is it, 9:11? The moon may be up now. Did I not? That's definitely the proper filter. It's narrowband 2. But you see you can actually see the Heart Nebula there. Well, let's try something else. So as I said, when a star like this, or when stars like this are formed in a location like this, they will dissipate all that gas over time. And if there's a lot of gas left, it means it's a young location.
The moon just rose.
Yep.
Your location.
Yeah, that's what I figured by looking at this shot. Compare the difference. I mean, this is, well, it's only 30 seconds, but this was, this guy, how long was this exposure? Well, we can just go find out by looking at the information panel. And we look here. This was a 30-second shot, see? Right there. 30-second shot. Alright, and we did it double that time, and without the moon, it would have just been a little bit brighter, but with the moon, of course, we get that. However, if we use our narrowband 1 filter, which is the filter that I've got right here, I just moved that in, and we go take a photo again with that filter in place, same photo. Now let's go see what we have coming in for us. And we'll also head over to Mars too. Once the moon comes up, it's just clusters, or it's the moon itself, or planets. I was going to tell you before too, when we get to Arizona, images of these objects like this that are very faint, typically here in Connecticut, will just be jaw-droppingly staggering, I guess is the way to put it. I took 30-second shots with my camera on a tripod, and I saw the faintest parts of the Orion region without any problem. And that was just crazy. I saw what's called Barnard's Loop. Look that up. I saw the Horsehead Nebula, clear as day. I saw the Flame Nebula. It's fairly bright. And, of course, the Orion and the Running Man nebulas. I mean, just amazing stuff. And very, very clear. There's also a phenomenon that you're subject to. You may know the sky as well as you know the sky, but then when you get under a really, truly dark sky, you have trouble picking out the most obvious constellations. I'm not kidding. Orion is an easy one to pick out, but like Cassiopeia, the W of Cassiopeia, that you typically might not be able to pick that out, right away if you're not sure, because all the stars look bright in Cassiopeia. So it's really amazing. Hey there, Anna. How are you? She has stopped saying my name. What name? What name we say, Anna? I think she was being funny, but I'm not sure. I think we should look at the double cluster before we head over to Mars, don't you think, Daryl?
Sure.
Yeah. Okay, now here's an idea, just to give you an idea. Okay. That previously bright image with the somewhat wider narrowband is much darker with the regular narrowband. Now, it doesn't look like there's a lot of nebula in here, but you'll be very surprised because you can actually see the nebula here. See it? It's pretty clear. You're not used to seeing it as your eye doesn't pick it up, but the camera does, and then the computer does when you process it. You can get the most information that's amazing out of these things with it. Just very cool. All right, now let's check this out. Let's go here. This is a wonderful little cluster, and I'm hopeful that it will show nicely. First things first, it's going to bring a star in to guide on. And I'm just going to take us back one level so we can see all the stars. And we should see that cluster come right in here. And we do. Look at that. The double cluster is just beautiful. It wasn't those two, actually. It was this and that over there. This is the double cluster. It fills the whole view. So we're going to check these out. These are two clusters. One's actually closer than the other to us. But it's a line of sight thing where they're kind of like this. Well, you can't really see that, can you? They're kind of like one's close here and then one's a little farther out here. But from our point of view, they look like they're right next to each other. But in reality, they're separated from each other. It's possible that they indeed were formed at the same location at one time. Anyway, we're here. We got it going. And let's go into narrowband 2. And we'll do that now. We'll drop down the sensitivity because we don't need it way, 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 way up there except for stars. You'll see some of the stars go away as we do this. Let's just go and do 800. And let's just do it for like 15 seconds. Okay. And now you'll see some of the stars. You'll see how this looks. This is the main cluster is here. One cluster is here and the other one's just out of view. Okay.
Double cluster is a good binocular object, actually.
Actually, Daryl's of course right, and I'm remiss in not telling you guys that. You could see it with your naked eye, and I'm just trying to give it to you at various. Let's see, we're narrowband 2, so I'll just take us up a little higher here. Let's go to 3200 at 15 seconds. It's beautiful. You'll see as we. What's that?
I said it is.
Yeah. And I'll show you in Stellarium where it is in the sky. and you'll see that it's actually something that's pretty easy to get to. Look at all these stars, my gosh. And let me actually increase our speed here. I'm going to cross that threshold. I'm going to go 25 seconds. Here we go. And now let me actually also do something else. Let me move down and move west a little bit. Let's try that. And now I have to wait the obligatory 11 seconds. Okay, that should be good. I love starry skies. Let's go back to our view here. Ah, yes. The double cluster is an interesting cluster, okay, because when we look at it like this, you'll see that it has two stars here that are actually quite orange. And there's another one up here that's quite orange, and several others. Now, here's something to understand about that. When you look at star clusters like this, you say, hey, it has stars of all different colors in it. Well, that's actually not possible. So you'll say, wait a minute. I'm looking at them right here with my eye. How can you tell me that's not possible? There they are, right there. Hello. You know, quit being stupid, Mark. Look at them. They're right there. Well, the truth is, when we look at them, we're actually seeing stars that are in the same line of sight. So stars like this guy, this red one right here, are actually up here, closer to us, or farther away. And the cluster is at one particular distance as a whole. And the other stars we see are either closer or farther away. So it's sort of like a superimposition issue for those kinds of stars. Because when you're looking at a cluster like this, most of the stars we see in these clusters are actually created together. So they tend to be all the same type. You know? So I'm going to move us over a little more. Move a little more. Okay. A little more. Okay. And just go like this. There we are. Let's see what this will do for us. What I did was I just was in here moving us, getting this in here more. I think that this might do a little better. Alright, let's take a 25-second shot at 8,000 ISO. As you can see here, 25 seconds for 8,000. Not bad. Okay. There we go. That's more like it. And there you can see the double cluster. Look at that. Isn't that beautiful? I can't remember which. I think this cluster is closer to us than this cluster. They're approximately the same angular size to each other. So this one looks a little bigger, I think, because it's closer. I'm not sure which one. Daryl, I don't know if you know which one is closer.
Not offhand, no.
Okay. All right. Now the question is, where is this in the sky? Well, let's.
Perseus.
Yeah, let's bring up our wonderful little star map here, and you say, well, wait, that's not helping me. What's all that stuff? Well, let's just add the constellation lines to the mix, and you'll see something very impressive. Here is the W of Cassiopeia. Okay, and let me give it to you this way so it's a little better. Here's the W of Cassiopeia right here that you can see. 1, 2, 3, 4, 5. Okay, and down here between this N star, okay, which is called Sigyn or Sigyn in Cassiopeia, and this star down here in Perseus, which you can also see in the sky. You can also see Merfac down here. Okay, the Merfac's probably the most obvious one too. You might see Gamma Persei, but it's really interesting because this is the N star in Cassiopeia right there. Okay, so that N star of the W, draw the line down to Perseus, and just look a little bit to one side, and there's the double cluster. You can't miss it. It's right there. You'll see it with your eyes, and you'll see it with a telescope. You'll see it with binoculars. So it's just a beautiful cluster, which shows up obviously late in the summer or in the autumn or the fall, and it'll be there all winter long. So it's just a really, really beautiful sequence or smattering of stars. And of course, the way these stars are in the sky is very simple. You see the W of Cassiopeia, and you say, well, where is that in the sky? Well, let's back out a little more, and you can see that it is actually, and let me get rid of these lines here and bring you these other lines. Okay, this is the North Star right here, and this is the Little Dipper. Okay, that's the Little Bear, okay, which you see. All right, and the Great Bear is down here, the Big Dipper. You can see the Big Dipper right here. 1, 2, 3, 1, 2, 3, 4. These are the bowl star, the bowl of the Big Dipper here. These two stars point to the North Star. And Cassiopeia in the northern hemisphere is a constellation that we call circumpolar. It never sets. You see, the Earth rotates right like this, okay? So it actually rotates like this. So rotating like this, all right, Cassiopeia is getting higher and higher in the sky, but it never leaves this circle, okay, in the night sky. When it comes down here, it's going to be down here, down low, all right, but it won't ever set. So technically it's always up, right? So look for that W, okay, and right now if you were to go outside, what you would notice is that that Cassiopeia is up in the northeastern sky right now, very high in the northeastern sky, all right, and the W is open toward the North Pole. But you follow that W, 1, 2, 3, 4, 5, go to that last N star, and then you'll see this bright star down in Perseus. So you start heading toward that star from there, from the N star, and as you do that, you'll see a fuzzy patch just off center from that line, and it'll always be to the right of that line when you're looking at it, all right, and it depends how you look at it, of course. As long as you got if the top of your head is facing the North Pole, like if you tilt your head like that way, then it'll always be a little bit to that one side. And there's the double cluster right there. And we can turn on our indicators. You can see double cluster, you know. And it's a really beautiful sight, as you can see right here.
Double your pleasure, double your fun, double mint, double cluster fun.
There you go. Well done. Want to say hi to Champ? How you doing there, Champ? Champ Boyles Gaming. Hey, nice to see you. You said, where is it? I answered your question. There it is. And there where it is in the sky, it's halfway between the W of Cassiopeia and Perseus. But it's technically in Perseus. I can show you that too, because all we have to do is bring up our constellation boundary lines, which are those little red lines, and you can see that Cassiopeia right here. 1, 2, 3, 4, 5 stars. Come down toward Murfak and actually toward Perseus. But as you get down here, here's the double cluster. And here's the state border for Perseus right there. And this is Perseus and this is Cassiopeia. So technically it's in Perseus. Perseus. But what a beautiful shot. I've always loved this object. It was one of the first ones I looked at when Orion wasn't up yet. When the Orion Nebula was up, I was like, wow, what's that thing? Whew. And I looked at the Orion Nebula and was blown away. So, you can also be prepared to be blown away once we get the Orion spectacle coming up for us, and it'll be pretty. So, let's see. Now, what I have to do is, I'm glad we could see the double cluster tonight. In our telescope, I want to look at the telescope view here. Let's bring up the telescope view here. Alright, started it up again, and alright, well there we are. We're looking out into the dome. You can see that we're looking quite a bit toward the northeast up there. Okay, you see up there we're looking quite a bit toward the northeast. And if I go any further over here, which is kind of where Mars is out over there, even further to the right by more than half the screen, we will not be able to see it because the dome will be in the way. So you know what that means. Daryl, you know what that means.
They have to put up with me for a few minutes?
You got it. I'm going to go move the dome while Daryl talks to you. He's got the most amazing stories. He's just really cool. I hope you like him as much as we do. If you don't, you can complain to the management and we'll still do absolutely nothing about it because we still like him.
Okay.
All right, I shall be right back. I'm going to go move the dome. Now, you notice when you look at this image over here of the dome, all right, this is a real dome, okay, that you're seeing here. And out in Arizona, we're not going to have a real dome. The reason? We don't want a dome, okay? We want something where the roof just goes away, all right? Because when you take the roof off a dome, or you open the shutter in the dome, which is that slot, you see that black slot, there's this space beyond, then it takes time for the air to reach the ambient temperature and to be the same stillness as the outside air. The domes are good because they prevent dew from settling on the telescope a little better. A roll-off roof observatory, on the other hand, will have a lot of dew issues in the north. In the desert southwest, on the other hand, at the desert southwest, it's just not the same. There is humidity in the air, believe it or not, but it's not the same. So I have an anti-dew system on the telescope here that will work brilliantly out there, so we don't even need what's called a dew cap out there. Anyway, hey Bob Harless, welcome back, and Elliot Astro Imaging is here. If you guys haven't seen his channel, please go subscribe. He's got a great channel. He captures images live, does some fantastic work too. I just thought that I would let him know that I know that too, and I've seen it. Hey Gas Mask. So I'll be right back. I'm going to go move the dome so we can go look at Mars.
Okie dokie.
The con is yours, Daryl.
Very good. What shall I amuse them with? If you look at the sky map Mark put up, there's the bright star Capella rising in the northeast, constellation Auriga. Auriga is the charioteer. Capella is called the goat star. We can't quite see it there. If you look really close, just under the P in Capella, there's a star. Then there are two more stars to the lower right of that one. Those are called the kids, as in baby goats. I guess you would say Capella, though it's a goat star, is the head of Auriga, the charioteer. For some reason, he's carrying baby goats in the crook of his left arm. And that's what the kids are. And above that, as Mark pointed out, you see that crooked W is Cassiopeia, the queen. And to her upper left is that upside down house shape. That is Cepheus. He's the king. He's Cassiopeia's husband. Over to the right of Cassiopeia is Andromeda. She's Cassiopeia's daughter. And then to the lower right of Cassiopeia is Perseus, the hero. And that's the story. I've told this before of if you ever saw the old movie Clash of the Titans, the one Ray Harryhausen did back in the late 70s, early 80s, I guess. Cassiopeia boasted of Andromeda's beauty, and she managed to offend some minor godlets or something. I forget who they were, the Nereids or someone, because they thought they were prettier. And they complained to Poseidon, if I remember correctly, and Poseidon told Cassiopeia, well, for your effrontery, you have to sacrifice Andromeda. We're going to feed her to Cetus, the sea monster. And they chained her to a rock, and here came Cetus, the sea monster, which nowadays is the whale. You know, cetaceans, Cetus the whale. But Perseus, he had the hots for Andromeda, and he rode to the rescue on Pegasus, the flying horse, which is also up in the area, just out of view. And he had already cut off the Gorgon's head at that point, and he had the Gorgon's head in a mask, and he pulled the head out and showed it to the sea monster and turned it into stone. And he saved his girlfriend, Andromeda. And that's the story. Mark is back.
That's a great story. I love when Daryl goes into some of the mythology, myths, and the historical culture. That's really cool stuff. Hey, Martin. Yeah. Marcin Johansson's here. Oh, look at that. There's our bright red friend. Say hello to my little red friend. That's the planet Mars, folks. And we will be looking at it, and looking at the telescope, I can see that we have no obstructions, so we should be good here. The nice thing about this is that we can take very short exposures, and I'm going to bring down our sensitivity here to literally 50. Alright, and we're going to go, instead of 25 seconds, we're going to drop down to just under a second. Wow, I can actually see detail from here. I was outside looking up and I noticed something a little disheartening. Looks like we have some high altitude haze. I can't even see the Milky Way anymore. And normally the Milky Way is pretty prevalent. So, but for a 13th of a second at 50 ASA, let's see if it helps us with Mars. Let's see. Sometimes it does. It's an oddball thing. Okay, so let's bring us in here. Okay. Well, look at that. We got some interesting views there, but I gotta sharpen up this image a little bit. Haze might be causing it to degrade a little. We can see something there.
Is this with the number 2 filter?
Yes, it is.
Okay.
This is with narrowband 2. All right, let me go back to this. Let's go into our focus mode. All right, we're gonna go into the focus mode here. All right, this is where I want to focus. Where'd it go? There we are. All right, so we're gonna actually make this our location where we bring objects to focus. And I'm going to bring Mars there to focus. Okay, so you may not see it, but I do. There it is. Alright. Okay. Now we're going to run it through a focal test here. Okay, you can see Mars is bloated and out of focus now. So I'm going to take it, bring it down into focus.
Mars is rising earlier and earlier. Mars is up here before 7:30 at night now.
Yeah.
Wasn't that long ago I was saying it wasn't up till 10 o'clock, then 9 o'clock, and now it's up by 7:30 my time.
Yeah.
It can depend where you are, how far east or west you are in your time zone. It may change that somewhat.
Yeah. Yeah, he's right.
And by next week, it'll be rising at sunset when it's at opposition. It's just like a full moon. It'll rise at sunset, set at sunrise, and it'll transit the meridian at midnight when it'll be highest in the sky.
And it should also be rounder.
This is true, yeah. We've been seeing it in a waxing gibbous phase recently, and it should be fully illuminated or, look like a real disk at that time.
That's because it's in line with us and the sun, straight out. Like when the moon is to one side or the other, we see it in a phase, right? Well, the outer planets typically we don't see phases because they're so much further away. But because of the location of the Earth and Mars in its orbit, we can see Mars when it's sort of in that gibbous phase. But that's about it. We don't ever see a half Mars, for instance, like a first quarter moon. We don't ever see that. But we do see it in this manner, the gibbous phase. All right. Yeah, see, I'm trying to focus it through the haze. It just doesn't like to focus tonight. That's okay. We have to take some photos of it to make sure we're doing the right thing anyway. See, typically, you see the image gets bloated. Okay, that's way out of focus. The smallest image is the focused image. So right about there. Let's see how that looks. Let's just do a quick view. And let's bring that over. Bring it in. Almost there. Wow. That's pretty cool. I know that looks kind of weird to you guys, but hold on. Look at that, Daryl.
Uh-huh.
That's interesting. Now, in previous nights, we've seen the polar cap right here. We've seen surface detail like we're now seeing. And what we should do is just do another shot, but we're going to go to the most narrowband filter. This is narrowband filter 1. Let's check that out. Now, first of all, we have to increase the exposure a little bit, make it a little longer because it takes a little more light to get this information in. But we've seen some incredible differences. And we do again tonight. Look at this. Look at that. Yeah, this narrowband filter really works well on the planets, Daryl, huh?
It does.
You'll notice
I can barely see the South Polar Cap on your screen, at least. A little white dot, tiny white dot there at 7 o'clock.
Yeah.
As I said during our last stream, Mars's day lasts about 24 hours and 40 minutes, if I remember correctly. So if we look at Mars the same time from night to night, that dark object, for instance, we see the big one pointing up toward the top of the planet, will actually seem to move from right to left, from night to night. The planet is actually rotating from left to right. but because Mars's day is just a little bit longer, we will see it kind of offset the same time each night back to the left. And I suspect what we're seeing right there is Syrtis Major, the large dark feature that's reaching up toward the top of the planet. And that would be the Hellas Basin directly below it, right about there. We need to pull the map up to tell more. Sinus Abaeus, I've talked about before, is kind of moving off to the right side, to the left side.
It's actually out here, actually.
I think I can barely see the edge of it toward about 10 o'clock.
Let me hold on one second there, Daryl. Don, no, the color is kind of a purple color. It's not your color being off. We're looking at this through filters, okay? So the filter is going to bluify anything that it sees. But the benefit is we're actually seeing it in very close to as much detail as we can get here. Okay, now what I could do just to help with this is I'm going to help you with color correction. I didn't mean to cut you off there. I just want to.
That's fine.
Get to someone who was saying. So maybe this looks a little better. This is just a little shifted color for you. And then you can see the polar cap actually really well now. Yeah, that's the South Pole cap right there. Okay, and the South Polar cap is right there. All right, and it's pretty cool. It's a tiny little guy right there. And he's talking about, this area right here. All right, this area you're looking at here, this is Syrtis Major that he's talking about right here. And then we got this area down here, which sort of moves here all the way down. You can see it moving down. We can identify that for you as well. I just have to bring up the Mars map to do that, which I think I may still have here, Daryl. I'm just working on getting that Mars map, guys. 1 second.
Yeah, it's called Mars Carta Planeta, or Planeta 2.
Yeah.
If that's how you filed it.
Yeah. I have it. I'm trying to get it now. Let's see if we can open it. There we go. And now if I go to it, there we are. So this is the Martian map. The Mars map right here. I know you want to read those things, guys, and then I'm gonna try to make them readable. And we're looking at right here. This is what we're looking at, Syrtis Major, and that white area below is down here. This is the Hellas Planitia. This is a basin, but a very white one, brighter area. Then this is Terra Terrena right here, and then we have Hesperia over here. This is that dark area, that large band that we're seeing right now on Mars, right here. Right there.
I think we could almost I could see something to the upper right of Syrtis Major, that small dark feature they show there.
Okay.
I think that might have actually been showing up in that image.
Well, let's go see. Now you got me excited. Let's go see.
It's at about 1:30 or 2 o'clock.
This here?
That right there, yes.
Interesting. All right, maybe he's right. Let's first go. Oops, didn't mean to do that. Let's bring that up. Let's go take another photo, because one thing to keep in mind is that as we take photos, these photos tend to be they tend to be better or worse depending on how we do it. Okay. Well, that's interesting. So this is
maybe that was an artifact I saw. Maybe. I don't know. I see something dark at about 1:30.
Yeah. This is Syrtis Major here. Then we have Pterina here, and we have Hesperia over here. This bright whiter area here, this is the Hellas Planitia. And that's an area that's sort of devoid of craters. So, I mean, there's craters there, but it doesn't have the same kind of rough terrain as some of the other spots. It's sort of a basin, which is really neat. Nice place to go. I don't think I want to live there, though. Pretty darn cold. Hi there, Ozzy. How are you? You may ask a question, of course. You ask away. So it's really pretty. I mean, this is really nice. All right, I'm gonna change something. Okay, I'm gonna just change a little of the color. Okay, a little color here, just a bit.
That's rather nice. And my brother just emailed me. He took a look at Mars in binoculars and couldn't see much. So I gave him a link to the stream here. Hope you don't mind.
Of course not.
Okay, hopefully he doesn't embarrass me. No, that's a really cool picture.
Yeah.
And
Ozzy has a question too, but go ahead. Go ahead and finish, Daryl, because I want to answer that question as well.
Oh, that's fine. Go ahead. Do you think Mars will crash into Earth? Is that the question?
Yeah, that's a question. Yeah, Ozzy, the answer is no. I do not. And the reason is because Mars is only apparently closer to the Earth because as we orbit the sun, Mars takes a little longer to orbit the sun than we do, and we kind of catch up to it. And as we orbit the sun, we're orbiting the sun. Mars is also orbiting the sun. It takes a little longer for Mars to go around the sun than we do. So we kind of outdistance it each time as we approach it. Okay, there's a point where we're going to be as close to Mars as we can possibly be as it's making its orbit around the sun. We'll be approaching Mars and get to that spot, and that's where we are right now. So Mars will appear larger in our sky. There's times when Mars will appear way less than this size by more than about half. And that's because of the fact that it'll be on the other side of the sun while we're on on the opposite side, obviously. So that's something that will cause us to actually see Mars at a different size in the sky. And so we won't see as much detail on its surface. We see the most detail, obviously, the closer we get. You can see the most detail of our planet because we're on it, and we can look down and see the very fine sands and everything. To see that on Mars, we need to be there. And the new Perseverance rover is heading there now. It'll be there in February. And it will land, and it will also drop off and control the first drone flown on another planet, and that is the Ingenuity helicopter drone. And I saw a flight test of Ingenuity, which I think some of you probably saw, and Ingenuity was quite a good performer in the simulated near vacuum of the Martian surface. Ingenuity is taking advantage of the very thin atmosphere on Mars, and it's going to have these very large 4-foot length helicopter blades that are steeply pitched and wide to capture a lot of the thin air on Mars. And it can fly, and it will be able to fly around Mars, and you'll see the first drone view from above. You'll see the Perseverance rover itself as seen from Ingenuity. It'll be really kind of a cool thing. The other thing that that particular system is doing, that the Martian Perseverance rover is doing, is this rover. See, this planet is mostly 98% carbon dioxide atmosphere, and there's very little oxygen, very little of anything else. But it's 98% carbon dioxide. Now that's CO2, a carbon atom, and 2 oxygen atoms. Okay. Now, what we can do with CO2 is we can actually manufacture oxygen from it. Now, the reason we can manufacture oxygen that we can breathe is because of the fact that it's already there. We just have to pull the carbon out of it. But it's not as simple as saying, well, just remove the carbon, you got O2. Unfortunately, it doesn't work that way. In chemistry, we need to take multiple CO2 molecules, and we need to make them into something else in an intermediate stage, and then the byproduct is something that we can make into the oxygen that we breathe, which is diatomic, or two atoms of oxygen, O2, right? So the way that experiment is, the Perseverance rovers actually got an experiment about the size of a car battery, and it's called MOXIE, and it stands for Mars Oxygen In Situ Experiment, and it's going to be able to see about generating oxygen from the CO2 atmosphere of Mars for purposes of creating both rocket fuel and breathable oxygen. We can't go to Mars with all the oxygen we can ever breathe, because that'll be disastrous. It won't work. And certainly we don't go to Mars expecting we're going to make a quick round trip. We can't bring all the fuel to get us all the way back home. We have to manufacture it at Mars. And to do that, we actually have to create a system to build oxygen molecules out of the CO2 atmosphere. And that's just what we're going to do with the MOXIE experiment right on this red planet. Now, here's a good question for you guys. Mars is a planet that in some ways used to be kind of like the Earth. It used to have an awful lot of water, and it had a much heavier atmosphere. But unfortunately, the reason that Mars lost its atmosphere, it's speculated. We know ways that a planet can lose its atmosphere. One of those ways is it can lose its magnetic field. Now you'll say, well, what's a magnetic field got to do with it? Well, magnetic field is a envelope called a magnetosphere, we call it, around the planet, which actually traps high energy particles coming from the sun. Those high energy particles, if allowed to hit the atmosphere, will strike things like H2O, water vapor, and that water vapor will then be ripped apart into hydrogen atom and two hydrogen atoms and an oxygen. And the hydrogen atoms will go off to space because the planet's gravity is nowhere near enough to hold the hydrogen down long term. And the oxygen will just sort of sink down and end up going down into the crust, where it will bond with other things. And that's why Mars is the color you see right here. Mars is this red color because, my friends, it rusted. Okay, and that's really what we're looking at. We're looking at something called, we're looking at various forms of a mineral called hematite on Mars. And so when we look at rust on Mars, oxygen from that high energy ultraviolet radiation that struck the Martian atmosphere ripped apart the water molecules. The oxygen went down into the crust, and it took 3 of those oxygen atoms to bond with a couple of iron atoms, and it makes Fe2O3, which is rust. That's one version, and there's several other versions. So this is what happens, you know. This kind of stuff is interesting when we figure it out. Now, why did Mars lose the ability to have a magnetic field? Well, unlike the Earth, where we have we have a solid core with a molten outer core that's rotating around, and it rubs against that inner core that's solid, and that generates electricity through the charge that's built up between the iron compounds. It's like a static charge, okay? Like rubbing your feet on the carpet, but on a planetary scale. And when you do that, that charge actually causes the electric field, which of course is then tantamount to creating a magnetic field. Because if you look at what happens, every charged electrical wire has a magnetic field circling it. Okay? If you put a charge current on a regular copper wire, you can move a magnet detector if you want, a Tesla meter as they're called, and bring it close and you'll see it go up. Hey, look at that, huh? And that's because of the fact that electric fields can generate and do generate a magnetic field. Well, It's called the dynamo effect, and Earth created that dynamo in its core with its solid core and molten outer core that's rubbing against that solid core, held solid by pressure. And so that created the dynamo on Earth, which creates a magnetic field. We call that a magnetosphere, and the area where our magnetosphere drops off is called a magnetopause. Okay, and Mars used to have a magnetosphere. In fact, areas on Mars show residual magnetic field, but no real alignment to anything left. The reason is because Mars' outer core probably cooled to the point where it no longer is causing the electrical currents in the core, the dynamo effect within Mars, to create a magnetic field. So Mars without a magnetic field allows the high energy ultraviolet radiation from the sun to reach all the way to Mars and strip the atmosphere of Mars slowly but surely over millions and billions of years. And so Mars' atmosphere is only about 6 millibars, okay, which is really compared to over 1,000 here on Earth. It's really not a lot. It's effectively a vacuum for humans. You could certainly never breathe in that. So, what do? Well, we take that carbon dioxide atmosphere, what little there is, and we convert the oxygen. We convert it to oxygen so we can actually have oxygen to breathe there. And that's what the Ingenuity rover is doing. I'm sorry, the Perseverance rover is doing. And then they're actually bringing pieces of astronaut helmets and spacesuits to Mars, little samples, and they're looking at what the long-term effects will be on these materials at Mars. Why are they doing that? Because we plan on going there, guys. We're going to Mars as humans. We're going to be walking on Mars sometime in the next couple decades, perhaps. I'm going to be, that'll be really impressive. Really impressive. Elon Musk has talked about it. And, frankly, it's hard. Going to another planet is not easy. And going to another planet that has an atmosphere is very, very difficult because you have to re-enter that Earth, that planetary atmosphere like we enter Earth's atmosphere. And even though it's a thinner atmosphere, it still poses deadly dangers if we don't do it right. So there, end of lecture, sorry. I'll take another picture and be quiet. No, look at that, Daryl. It's looking good.
Uh-huh.
I dare say, I think that this light haze is helping our Mars views tonight.
It can do that sometimes.
Yeah. But this is it. See, it's kind of cool to look at Mars and see more than just a little red dot, and many times in the past you've looked at Mars. It's unimpressive. But look how big it is. This is looking rather impressive now. We can see features and everything. This is really, really nice. The Martian was a good movie and a good screenplay, actually. Yeah.
I've yet to see that movie.
It's actually...
I'm not a big Matt Damon fan.
Yeah, that's okay. But the thing is, it's definitely a movie that does follow the science, I have to say. It follows the science and it doesn't deviate.
Yeah, well, I'm old. I liked Robinson Crusoe on Mars.
Robinson Crusoe on Mars was a lot of fun. That was a great movie.
It was.
For those of you that haven't seen it, Robinson Crusoe on Mars, check it out. It's a fun watch.
Whoops. Yeah, that's the kind of stuff I cut my teeth on.
Yeah.
Now, I can see it looks like Mars has rotated a little bit since that last image you took.
Yeah, let's go back and look at that last image. Okay, that's the last image. Let's bring it as close to where we could as we could before. Let's bring this one up a little.
Maybe a little bit.
All right, let's bring this up a little bit.
I was curious. I'm seeing some a couple of light spots in the last image up at about 1:30, 2 o'clock, and
This image?
dark stuff too. Those may be artifacts. I'm not sure because I don't see them in the newest picture you took.
Okay,
The light spots, at any rate.
This is the newest right here.
Yeah, hard to tell.
All right. Keith, P&K, you gonna clear that up for us? I hope you do. Like I told everybody, you guys at P&K Space Imaging are the definitive planet watchers and moon watchers. You have that down. We are the definitive deep sky, hopefully, and Bill, New York Skywatcher, is the definitive meteor and wide field camera views. It's fun to just it's like sitting out on Bill's lawn and watch the meteors showers, Just watch the meteor stream by. It's like a lot of fun. And you do it in all as a group. Here, it's almost like we're all sharing the telescope eyepiece together. And that is what I like to do. And then Paul and Keith, they show the moon. And when they show you the moon, it's really pretty, absolutely stunning. And the planets look beautiful. They have special equipment to be able to actually show the moon and so forth. So much more detailed than any other stream out there. And so make sure that you guys subscribe to P&K Space Imaging. Also, don't forget to subscribe to Bill New York Skywatcher. And if you want to find all of us, you can find us on astroimaginglive.com, an actual website, not Facebook. astroimaginglive.com. Our pictures show up on the Facebook SkyTour live stream site. I put them up there. And we end up putting our processed photos up there as well. I'm still working on our processed photos, and as the other night, I'll do it again tonight. I'll do it right now. You see Mars right here, okay? It's Mars right there. See right there? I'm actually going to move it over a little bit, and I'm going to take a video of Mars. And why would I do that? Well, I'll tell you in just a minute. Let me, first of all, bring it over here, and now let's head east a bit. Okay. Now, we're going to go and we're going to change the camera's settings. You'll see them. We're going to go into video, right? And now we're taking a video right now. And we'll just sit here and wait. Now the video is 1/30th of a second per frame. So that means 30 frames per second. So, that's right, D. Smith. P&K rocks. P&K rocks. And Bill New York Skywatcher is indeed awesome. So at 30 frames per second, it means that at the end of 30 seconds, we have 900 frames. Now, when we take a photo of a nebula, for instance, we take maybe 30 or 40 frames, and then we stack them on top of each other with a special software. Well, we're going to take the planetary images, which are just single round images that regular stacking software can't really handle too well. And we're going to stack them a different way. And that stacking process will provide us with an incredible clear view of the planet. And so we're going to do that. So I've taken about 30 seconds. I'll go a little longer. And then I retrieve the images of the video from the card. And then I will stack that. And we have to stack... There we go, I'm done. We have to stack only the ones that we get from this night, from this one particular photo. We can't stack the previous nights or anything like that because Mars rotates. and it'll all be messed up. We can only do a run of, I don't know, a minute at the most here, and then we have to stop, and then we can stack that. So that's what we're gonna do. So let's just take a photo here and see what we're looking at. So if you imagine, okay, if you imagine we photograph Mars again, okay. I mean, look at that. That's looking really nice, Daryl. Holy cow! Look at that. That is actually stupendous. Holy cow!
Mark, could you excuse me a moment, please?
Yeah. Hey, look at that, guys. Look at that, huh? Hey, Papa Tom, how's it going? Just in time to see a beautiful Mars. Look at that, huh? I'm really amazed at that. That's really pretty. Okay. You really got this beautiful line here of Syrtis Major there. That's gorgeous. And this other area down here, Hellas Planitia down here. And then there's some other detail that's up further. Wow. This is really pretty. A moment of good seeing. Let's take another picture. I like it. Wow, it's I gotta say, it's not bad. It's not looking bad at all. It is not looking bad at all. Say process some noise away and it's kind of fuzzies it up. That's why I use these guys. These are the raw files. See how sharp this is right here? Sharp that edges. If I use the softer image, a little bit of noise removal kind of adds fake detail. We don't want that. Looks really pretty though. Well, the polar cap is down here around 7 o'clock, as Daryl had said. You also notice at the top here, you notice there's like a hazy white covering over here. That's not an artifact of the image. That's actually called the polar hood. It's a sort of a frosty vapor over the North Pole of Mars that makes its way over here. You see it, okay? Very, very clear, relatively speaking. So I'm finding that really, really interesting. Hey, Ronald. Ronald's here. ERRT radio. Radio. Ronald, why don't you type in what ERRT means so people see it and can understand what you're all about. So, that's pretty. I want to take another photo. The moon is up now, so it's possible, actually, we could just look at the moon, too, I guess. Who would have thought? We might be able to see the moon. Yeah. I mean, the moon is out there. Let's go take a look. We're looking at Mars here. And the moon is over there. I don't know. Mars looks pretty. It really does look pretty. Wow. So you guys, I hope you're having a good time tonight. We're having fun looking at Mars. We're just doing the Mars. It's like a Mars hangout now. Really enjoy it. And so this is technically the closest approach that Mars is to the Earth, and we actually can see some serious detail on that surface. I have the Martian map here. Okay, we're looking at let's show you where I'm looking here. We're looking at this let me bring it up first. We're looking at this region right here. That's what we're seeing. And then it goes down to this area. All right, and so that's what we're seeing. All right, and then we can also come back to Mars here for a second, zoom in, and this gives us a little bit of a view of it too. You can see Syrtis Major. Let me get you back to it, though, so you can see it. Okay. You can see Syrtis Major here. Okay. Come back. All right. And then we have Hellas Planitia right down here. There is a detail here which may or may not be there anymore right now. It depends on the season. Sometimes the darker areas that are underneath get clouded out. Not clouded out, but covered up by the lighter silt. One good dust storm could do it, like what happened with Opportunity. When Spirit and Opportunity encountered that dust storm. Dust storms on Mars rapidly go almost planet-wide because that dust is like talcum powder. And you know what it's like. When you blow talcum powder in the air, it gets all over everything, including the solar panels on your Mars rovers. Okay? And that looks like what might have killed Opportunity. But, that said, both of those rovers, Spirit and Opportunity, outlived their 90-day warranty. That's how long they were supposed to live. 3 months. 90 days. Can you believe it? And they outlived it by, I don't know, almost a decade. That's a pretty good return for your investment, I think. Hopefully we'll get the same out of the Perseverance rover. We also have Curiosity on Mars now, which is basically is the Mars Science Laboratory. It has the most elaborate and complete laboratory equipment to study Mars of any instrument we ever sent to any planet anywhere. It's the size of a Volkswagen Beetle, maybe a little larger, weighs a few tons, and it's actually just got an immense amount of capability. It has a rat on it, you know. There's a rat on the Curiosity rover. Did you know that? Yeah, it's not an animal. It's the rock abrasion tool rat. Little brushes that kind of brush away. I think I caught on the live footage when it takes, when I say live, it was delayed by like 4 minutes at that point. When they actually sent back this information from Mars, I could see something that looked like a prehistoric fossil we have here on Earth called a crinoid. It's a plant, and it is a segmented plant. And I thought, that's a crinoid. And I quickly called somebody that I know at JPL and said, hey, is that a crinoid? And he's like, I don't know. Some of us thought that it might be, but they already gave it instructions to drill more. And they wiped it out. So any potential direct evidence remains elusive. Just a sad day all around, you know. So.
Back, by the way.
You know, I heard. I was just. Ronald says something. They can do all this, and the $200 drone only flies for 30 minutes. What kind of stunt is this? What the heck are you talking about, man? I have no idea what he's talking about. Well, the truth is, it's not a stunt. Because if we go to Mars as a civilization at some point, we're probably going to want to fly around Mars. We're probably going to want to move around Mars. And maybe we'll be using personal helicopter-type devices for all we know. I mean, it's a great way to alleviate the load when you got to carry a load somewhere. If you can just fly and hop from one place to the next. You know, and if your little engine on board is something that's actually used as you know, a radioactive system to generate power, then maybe that would be something that would be helpful, you know. So.
Favor?
What's that?
Favor?
What'd you say?
A favor, please.
Oh yeah, I'm sorry. I didn't know you were asking me a question. I thought you were adding to something I just said, and I was trying to figure out what you were saying. Sorry.
Did we look at the planet?
Oh gosh, you want to see the planet now? Yes. Let me take another picture too. Yep, there it is. Stupid. Man, I don't like what's going on here. My camera is doing wrong things. All right, let's try that. See if that helps. Certainly helps. It's not there. Okay. All right. So let's just. Okay, is that gonna work now? All right. Maybe we're better. We don't know. Okay. All right, there we are. We're at the planet, Daryl. Good night, Marianne. That's weird. Look at that white thing out there. That might just be an artifact. I've taken another picture to see.
Yeah, I was just looking at that.
Let me take a picture and see if it's still there. No. Well, actually, we definitely have haze covering us right now, because look at that. We went from this kind of clarity to that. We're definitely getting a softer view. Definitely, it's a haze thing. And now it's back. Okay, now we got our clarity back.
Yeah, that might just be seeing moment to moment.
Yeah. Yeah, yeah. Actually, Ginga's blimp technology would be interesting at Mars. And if it turns out that we can actually manufacture enough helium, well, then the same amount of helium would lift far greater loads on Mars. But we have to be able to make helium from the soil. Because if we can't, then we can't bring it. We can't bring it to Mars. To bring it in liquid form would be the best thing, but liquid helium is really too expensive to try and maintain, especially on a trip that's going to take anywhere from 7 to 14 months. I don't know. I would have to guess, that astronauts are going to be dealing with enough problems. If you look at Elon Musk's capsules, right, that he has, and our Orion spacecraft, these are just capsules. These are not like the space shuttle even. There's not enough room to go and exercise and stretch out and just say, hey, I'll be downstairs working in the lab. There is no such thing. These are just functional craft to get you there. So it's quite likely that by the time astronauts get to Mars and safely land on Mars, that the gravity of Mars itself is going to be too much for them. It's very possible that will be a little too much gravity for them. They will have been away from Earth for a minimum of like I said, 10 months or so on average, and when that happens, your body begins to just sort of get used to where it is. You're going to be weightless for all that time. So unless they had an artificial gravity built centrifuge type thing, which is a great idea, then they're going to be weightless the entire trip. And when they feel gravity again, they could actually end up getting motion sickness from the ground because of the gravitational force. So it's a problem, So, I'm not sure. All I know is that when Mars was looming out of the window and they enter Martian orbit and prepare to leave the main ship to go down to Mars. It's going to be one heck of a wild ride. The Martian atmosphere is very thin, so they're going to end up having to use thrusters to land. They're not going to be able to actually land using, like the airbags that a couple of the rovers did. And, they're not going to be able to use the sky crane. The sky crane is only good for that smaller, like Curiosity-sized payload and the Perseverance type payload. But so they're going to have to use a different method. They're going to have to use what like Elon Musk uses here, rockets that land themselves. So, because the idea is you want to make a rocket land safely so you can get off the planet again and come home eventually. So it takes all of you out there, think about this. Would you want to get on a spaceship and go there? The uncertainty is unbelievable. And the environment is hostile. Thanks to Perseverance, we will know whether our spacesuits or space helmets will suffer any long-term degradation on the planet. And I think that it'll be pretty interesting to figure this all out. Hey there, Bray, how are you? Yeah, that was Mars out there on the eastern horizon and rising. Yep. Daryl, would you get on that spacecraft?
When I was younger and less risk averse, maybe. I think I'm too old for Mars now.
Well, maybe. Yeah, Daisy and Zoe. No vacations on Mars. Yeah, Ixnay on the Mars vacay. Yeah. So that's something. It's looking pretty tonight. So we took 35 seconds of video, and I'll take that video off the card, and I will stack it using something called PIP, Planetary Image Preprocessor, PIPP. It's free. You can all go get it. And you can process your own planetary images if you have them. I think you could, if you use video, that'd be the best, because then you could bring the video in and PIP uses the video. Nice thing is, it actually will take the it'll take the actual best frames and will throw out the ones that are not as good, which I think is really cool. Very, very good thing.
Try another picture?
Maybe. Yeah, here we go. I go a little longer here just for take us to 0.4 seconds. Yeah, that's what I thought. All right. I'm going to go. I know you guys are seeing kind of an impartial screens only because I'm not going back and forth to the screen as I should here. Let's shorten this now. Let's go 1/4 of a second from 1/3 of a second. Ooh-wee, Daryl. Wow. Look at that.
How long was that one?
1/4 second. 1/4 second. I'm going to go take one that's slightly shorter. 1/5 of a second. It'll be dimmer, but let's see. Wow. I think the 1/4 second is a little better than this, do you think? This is the 1/4 second right here. No, wait, is that 1/4 second?
You were shooting like a 30th of a second the other night, weren't you?
Yeah. But that was with the other filter. So, if we go and take another 1/4 of a second shot here. Interesting.
The longer the exposure, the more susceptible to local seeing conditions.
Yeah. So let's get to the smallest possible, lowest possible exposure. This is 1/8 of a second, so it'll be fairly dim right here. Look at that. I mean, it looks like that one's probably more detailed than this one. More detailed than this one. And if we go to this one. So this is the latest one we just did.
What if you were to bump your ISO up one step?
Yeah, I could. I was trying to get the lowest possible, but I can go to 80 or 64. Okay, so there's 64 in 1/8 of a second. Okay, I think we're going to do that again. Well, see, if you look at this, okay, you can see where the concept of the canali came from. These look like the Martian canals, okay? And I think that's Schiaparelli, wasn't it?
Schiaparelli called them canali.
Yeah, that's right.
And he meant channels. And Percival Lowell got carried away with it. When he read canali, he thought canal. So Percival Lowell drew the very fanciful maps of Mars showing the planet covered with canals.
Yeah.
As signs of intelligence.
Yeah. This is a good shot right here. So this is a good blend. This is 1/8 of a second at 80 ISO. Let's take another 40-second video of Mars right here. And what this is going to do for us is now give us more data that we can then stack the individual frames from this. Hey, C&D boy, how are you?
Folks, if you never heard of Percival Lowell, he was a rich guy back in the late 1800s, I guess, and Percival Lowell was captivated by the planet Mars. He built a big refractor observatory in Flagstaff, Arizona, and made Mars his study. And it's a heck of a telescope. It's still there to this day, I do believe. But Mr. Lowell got a little carried away. He started drawing maps of Mars and following Schiaparelli's idea of channels, which he considered canals on Mars. He drew some really fancy maps of the planet that showed Mars absolutely covered with canals. Big ones, little ones, all sorts, and they were crisscrossing all over the planet.
Yeah.
And he thought they were signs of intelligent life, you know, that, hey, somebody's digging irrigation canals on Mars.
Yeah, and unfortunately, not at all true.
Yeah.
Okay, we can stop that here, and let's see.
Well, you have to wonder, you know, if he ever got a good look at Valles Marineris, I could well imagine somebody thinking that's a canal.
Yeah, without a doubt, right?
Oh, yeah.
Yeah, this has been a good night here so far, Daryl. Look at that.
Yeah.
Yeah, this is probably one of the better nights we've had, guys. Looking at Mars, we're just taking exposure after exposure, and I took video as well that I'll stack and show you the final image. Typically, I mean, just to give you an idea, that's how big Mars is in my telescope. See that? That little dot? That's how big it is in the telescope. But because we can zoom in and check it out higher because we have some reasonable optics, we can see it a little bit better. And the idea is that for a big object like Mars or Jupiter, well, we end up finding that the atmosphere can kind of just like shimmer and make things momentarily be bad. So a fraction of a second that you take an image could be at a fraction of a second when that warm cell collides with a cool cell in the atmosphere, causing a ripple that ruins your shot. Hey there, Craig MK3, what's going on? There's a lot of good new faces here. If you guys are just finding us, please do subscribe to Sky Tour Livestream on YouTube. And you get shots like this and wonderful stuff. You got Daryl and I. Amanda couldn't join us tonight. I asked her to show up if she could, and she said she'd be here if she could. She's actually my co-host on Sky Tour Radio on Sunday nights on KGRA, 8 to 10 p.m. Eastern Time, along with Daryl Mason, who you hear tonight with us.
Ta-da!
Ta-da! So Daryl and I and Amanda bring you the world of astronomy for 2 hours every Sunday night. And we are going to do that. We will be live this weekend coming up. So store that in memory there, Daryl. We're going to be live Sunday.
We are?
Why wouldn't we?
Okay.
Yeah.
I bet we talk about Mars some.
You think?
Yeah.
We will. We'll talk about Mars. So, the other thing is, King, as you talked about, is that me or you, Daryl? Has to be me. Somebody driving by in a motorcycle or something?
Oh, sorry, that's me.
Oh, it is
Let
you.
me mute.
No, it's okay. I didn't realize. I thought it was me because I'm getting my sound directly from the observatory as well. The one sound we don't want to get, folks, when we're doing this remotely from Arizona, is the sound of rattlesnakes in the dome, because that will sound like psh, like a hissing, you know. And you'll say, "Oh, what's leaking air in here? Oh, it's that snake biting my leg." Yeah, that's not fair. That's not a good thing. DW, welcome. Yes, this is you've been here for a while. This is Mars, actually. Look at the detail on the surface. You can see Syrtis Major and several other features on Mars here. And in between moments of bad seeing, we have some that are really good seeing. And I keep going from this main view. Okay, there's our new STLS logo right there, by the way. Okay, I go from that one main view to looking at taking the pictures and getting us a shot of Mars once again with this view here. Wow. We're definitely getting some good views, Daryl.
Uh-huh. Looks a little soft. Do you think you might need to refocus? Is it cooling off there?
Yeah, it does cool a little bit. And I was thinking the same thing actually 2 shots ago. But I would rather try and focus on a star than Mars.
Yeah.
So maybe what we can do, I guess, well, let's try that. Let's just, first of all, we'll go for a little ride, guys. We're going to go back to our all view where the stars will show up. This is the straight through view right here. Okay, and then I'm going to go and bring us up a little. And we should get a star or two. This is 1/8 of a second though, so let's actually, there we go. There's the star I was looking for right there. And this is the white light view, and that won't necessarily be the best. So what I'll do is go into the view, which right now you say, hey, where'd everything go? That's only because I am bringing a star. Oh, there it goes. Bringing a star down to focus on here. And we're also looking at the through the filter view, or sorry, through the just a straight pass through view. This is not the filter view. Okay, this is without a filter. Filters change the focus, so that's why this looks out of focus. If I change this now to our filter that we're using, okay, that's narrowband 1. You'll see that there's nothing there. Narrowband 2, we should just be able to see the star image because it's that wider pass through the entire spectrum I was talking about. And let's focus on that star. You can see how it's bouncing around. We got a lot of haze in the sky. But let's focus again. Okay, so we're going to go way out of focus, which is what we're doing here. And now we'll go down into focus. Alright, and I think... Okay, now we're out of focus. Drop down into focus.
I don't know where you are located, but it'll be a very bright object, probably more in the southeast to you by now. It's unmistakable once you see it. It's very bright, and it has kind of a reddish or orange cast to it.
Yeah, it's very, very reddish orange. If you actually have color blindness, then look for the bright object in the sky. It will be it'll be a little bit more toward the south, like Daryl said, but it's going to be high in the sky, probably, right about there by the time you look at it. Wherever from here, that's where it is. If you're on the East Coast, then that's about right. Okay, let's focus on this star again. It's been notoriously hard to focus tonight because of the fact that this is we're having this problem here. Let me just do a 5-second photo here, see if that star shows up. It does. Okay, good. Let's see what it looks like. Okay, that's the star, not Mars. Let's go back to our view. And let's do this. This is just focusing, guys. We're just trying to get... This is the boring part of astronomy, man. I'll tell you. I used to work in big observatories, because after all, that's what astronomers do. And I would spend most of my time getting the scope ready to observe. Then I would do my observations, very short order, and then it'd take more time to get the scope ready and to get the scope put away than to actually... And these were in big domes too, so sometimes the scopes were 40 feet long. We had an old refractor that was just beautiful. And then I had a Schmidt-Cassegrain, which is just a massive... It was like a 24-inch. It was just a big, giant system. Okay, so let's just do this again. Let's get this focus straightened out here. Yeah, go way out and then come in. Okay, let's try that. Let's see what that does. Now we got to go back down to Mars. And
really jumping around tonight.
I know, that's the problem.
Yeah.
Okay, so now let's stay at 80, which I'm glad I could stay at that ISO, and I'm going to drop it down back to where Mars works best, and that was oh, I'm at the wrong filter though. I'm at filter 1. I need to be at, well, I can try filter. Let me try this. I'll try this filter. Here we go. 40th of a second. And Mars is right there. Yeah, no, the focus isn't right. Yeah, you know what I'll do? I'm going to just do it this way. I will... Yeah, because I got to get this... We'll do it this way. Okay. All right, we'll go back to this.
And the way it's dancing around now, the seeing might have gotten worse.
Well, we do have haze up there, remember?
Yeah.
So here I am trying to focus, and you know, I could be just like in an endless cycle of trying to get this to focus when it just doesn't want to focus. Usually it's pretty easy just to focus. That's actually a little better, Daryl.
There you go. I can see the South Polar Cap, 7 o'clock.
Right there you're talking.
Barely.
Yeah, it's kind of faint. But you can see Syrtis Major is really quite prevalent.
Yeah, it has moved
Considerably.
left to right quite a bit too.
Yeah, considerably. Here's another image taken earlier. Okay, you can see that's an image taken earlier. It's actually it's there, and then it is. Yeah, it's moved quite a bit. Look. Interesting. Let me go back now, and I'm going to take us to 50th of a second. Actually, I'll go right to a 60th. Remember, this is the other filter. Okay. Okay, that tells me what I need to know. Now I'm just going to grab us this other filter. We're going to go to the narrowband 1, the very narrowest filter. And we can't use a 60th. Now we got to use a much longer exposure. And let's try a 10th. Wow. So that's pretty cool. That's pretty cool. That looks nice. Look at that. Starting to see other supplemental detail. Not bad at all. Wow. I find that to be interesting. Okay, let's do one thing. Let's actually go a bit longer on that exposure. Let's go to an 1/8 of a second from a 1/10. So it gets just a little brighter. Trying to pick up that polar cap if we can. It's down here. You can kind of roughly barely see it. Now, what y'all think, Daryl?
I think the seeing was better earlier.
Better earlier, right?
Yeah.
Yeah. Well, there we go.
As you said, I mean, if you're dealing with haze,
yeah, makes it
haze
tough.
is weird. Sometimes it can actually help the view of planets. Sometimes it makes it worse.
Yeah.
It's been so bad here lately. Again, from the forest fires up to the north of here.
Yeah.
Northern Colorado and up in Wyoming, but it's really messing with the view here.
Yeah. Plus, we have a moon out now, which isn't going to do too much to the seeing, but we are looking at a interesting phase of the moon where we can actually see some really cool shadows. Should we look at the moon?
If you like, sure.
All right, we're going to try it. I don't know if the dome's in the way. Those are words I'll never have to say in Arizona, because we're not going to be using domes. Okay, there we go. You'll see the glow of the moon before anything else. But not until we get... Oh, there we are. Look at that. Actually went right to the moon. Which tells me that it probably...
I see Aristarchus.
Right there. You can't miss it.
I see Grimaldi down to its lower left.
Yeah, you can't miss it. Look at that.
Yeah. It's interesting to consider when you first caught the moon how dark it was to see how much that filter is really cutting down on how much light is passing through.
That's exactly right. That's amazing. Yeah, and just to see, guys, I'll show you what it looks like. It won't be quite in focus, but let's just go from this narrow band. Let's go now to straight through. Give you an idea. So, all right, let me just see. Yeah, you can still see Aristarchus right there.
Yep. And that's the brightest spot on the moon, and the darkest spot on the moon is that small crater down to the lower left of Aristarchus, over at about 9 o'clock.
Oh, I mean here?
That's Grimaldi. That's the darkest spot on the moon.
Mm-hmm.
Tycho is obvious there above 6 o'clock. Right there is Tycho. You can see the lunar rays projecting out of it.
Oh, sure. Copernicus is right there.
Uh-huh.
Plato is right there, 60 miles across, that little guy right there. Imbrium, this is the Mare Imbrium Basin. If you look, this is a massive impact basin. See how it's round? Because when objects strike the moon, even if they're irregularly shaped, the shape that they make in the moon, because of the energy distribution, is round. It goes equally in all directions. So that's, and if you even if it's at a narrow angle, if it comes in really narrow to the moon, you might say, well, then we get an elliptical crater, right? No, you get a round crater, and people don't understand that. But to see that, and understand that, here's what you think about. Next time you're at the lake, skip a stone across the water and watch all the concentric splashes that are made as it skips across. Every single one of those is a round crater, basically, of water expanding equally in all directions. Because the impulse energy that actually causes the crater is directly pointed down. Okay? And that's the force that's creating the crater. It's not the force of the angular motion. If it's going fast enough. If it's going slow, well then, yeah, it can drag out a long lengthwise thing. But typically that's not the case. This actually is not in focus. If we go to one of the filters, it'll be more in focus. Let's go. That's filter 1, and then this will be filter 2. Okay, and let's increase this exposure a little bit. Okay, and then let's go into focus mode. And look, it looks like seething lava. That's the problem called seeing. We don't really get a great. Hang on, let me move this over. We don't really get a really good view, unfortunately. That's the limb of the moon. You can see. Let's go to the craters where we actually can focus a little better. And the craters are most obvious near the Terminator, which is where we are now. Okay. Now let's focus again.
Well, it's really boiling up there now.
It is indeed. It is indeed, isn't it?
Probably what happened to Mars.
Yeah, for sure. No doubt. Okay, so now we can actually shorten this exposure a little. Alright, and let's drop it down a little. You know, they always say once in a blue moon, right? Well, the moon never does get blue when they say that only happens once in a blue moon. It's not because the moon is blue, it's because it's 2 full moons in a month.
Yep.
Alright, so here we go, 1/8 of a second. And yeah, see? There are times when we can actually get such beautiful shots of the moon, but it's kind of a rough, roiling night. Normally we can see detail inside Aristarchus, you know, but we're not getting it tonight. It's almost like we're looking at it through cheesecloth or something. Yeah, the sky is degraded, guys, a little bit, you know, and I really, you know, it looks beautiful nonetheless. I get it, you know, and I want to thank you guys for hanging out with us tonight. We're having a lot of fun. We got to see a couple of nebulae before the moon rose, and of course you saw what happened as the moon rose. It's rising in the same relative location where this nebula was, so it was making it kind of hard. Well, Isabella says she would go to Mars, but she would probably go to the moon first. Well, the only problem I would have with that is that I would always be able to look from the moon. I'd look out and I'd see my home on the planet Earth. I'd say, oh man, I want to go home. And you know, you can't say that at Mars. In Mars, Earth would actually be a dot in the sky. It wouldn't look like the Earth does from the moon. It would be, as Carl Sagan often said, a pale blue dot. And that pale blue dot is us. He goes, that pale blue dot, that's us. That's home. You know, that was a famous quote he said. He was my favorite astronomer, of course. So, yeah, pretty cool. Yep. Well, there you go. I mean, Daisy and Zoe. So here's your blue moon for Halloween. It's just early. Yeah. Yeah, well, we might have a blue moon this month with 2 full moons in October, but we won't have Halloween. We won't have to spend money on candy. So,
that's sad.
It is.
I've been thinking about it, what with COVID-19 and all this year. I mean, I always do something for Halloween and look forward to getting the trick-or-treaters, but I don't think I'm going to do anything this year. I'll just leave the porch lights off and...
Well, I don't think that kids are going to go out. I don't think they're going to be allowed.
I think there's going to be some. There will always be some.
Yeah.
And one of my neighbors has put up a grand Halloween display out in the front yard. Lots of those blow-up things that are popular now, you know.
Oh,
it's
yeah.
like a big Halloween locomotive steam train looking thing. It's got teeth and scary looking, scary cute, and ton of lights. And he's just really done it up. And I hope he's not planning on getting many kids.
Maybe he did it precisely because it just wanted to be showy on Halloween, so people could drive around and see it.
Yeah.
You know, you know. I'll tell you one thing. I used to do this. See, right now, the house I'm in now, I moved here because it's quieter. The Milky Way is better. But the house I was in before was exactly 5,280 feet from this one. Literally one exact mile. The difference is amazing in how the sky looks. I can't tell you why, but the localized lighting down that end of town was bad. Here, I have, and you've seen it, Milky Way from almost horizon to horizon here. That's on our all sky camera. You can see it. But in that other house, it was in a regular neighborhood, and so what I did was, see, one of the things that people really don't know about me, unless they go to fxmodels.com and start digging around, is that we make robots that go out and entertain. And we have one called Sammy, S-A-M-I, and we had one called Proto. Proto was about 5'6" tall, and it had a face made of light, and it could smile and look at you and do all kinds of gyrations and make gestures. Had arms that moved and everything. And it was actually a robotic system that we had created to entertain. And so on Halloween, I'd have Proto greet trick-or-treaters at the door. And I had to stop because it became a traffic hazard. Proto was inside the house, but I had 50 to 100 people on the front lawn at any one time watching the robot, because, the robot was a stand-up comedian. I mean, he would just go to town and start telling people jokes and talking to them. He'd make fun of their costumes and so forth, and they were absolutely loving him. So the police ended up being called several times. They came to direct traffic because cars were blocked by people standing in the road and other cars that were stopping to watch. And it became just nightmarish. Now, not for me. I was having a grand old time. I was getting Proto to talk to people, and I'll tell you, man, that robot was on that night. He was really on. He was like your typical stand-up comedian, and he really he really enjoyed it. He has since been disassembled. I had to no disassemble, but I had to. He started to show his age, and things started to be a problem, and when I found a mouse nest inside of him, that's when I decided it was time for Proto to disappear. So I kept the really good parts of him, the face made of light. I kept that, and the dome that his head was in, and then I, with great sadness, I disassembled him and cut him apart and took him to the dump to throw him away. I kept the motors and the motor controller systems, all that stuff we created. Much electronics had been eaten by mice, so I was like, oh man, yeah, my fault. That's what you get for storing them in a place where the mice got to them. So anyway, Terry Groff, how you doing, man? Good to see you. And chronic obstructive pulmonary disorder, that's what you got. Yeah, COVID would maybe not kill you at all, but it might be a very frightening thing to have. Yeah. That's chronic obstructive pulmonary disorder. That's what COPD is. No, I myself, my vocal cord, one of the vocal cords paralyzed here. That's why you have a chronic cough. I'm not sick ever. But that's because I had, strokes from surgery that went wrong. I had like 8 strokes on the table, and I was a blind quadriplegic for a period of time, and I had to spring back from that, which I don't think you could spring back so much, but I did my best. That was about 5.5 years ago. So it was just a minor interruption to life, right? And So I have an obstructed airway as well because that vocal cord, your vocal cords are like this, you know. And when they're working, they're both doing this. They're both moving in and out. Well, I have one that's stuck in kind of one place, so now it's right there, blocking the airway a little bit. So one's working, so you're hearing me because of one vocal cord. The second one doesn't even function. So that said, what I did was I just realized if I just figure out a way to get more air into my lungs each time, then maybe that'll be okay. So I've been working on exercises to do that. But if COVID came my way, I don't know what would happen. But I think, thank you, Tara. I think that I may have had it last February. I was doing a talk in Las Vegas, actually Laughlin, which is south of Las Vegas, and I remember there was one guy that was sick in the vendor room, and I shook his hand and realized he was sick, and I went and I washed my hands. But this is before COVID was even a thing, and so I ended up washing my hands really good because I just didn't want to get sick. Because after that I was going out into the desert to start working on the observatory site. And we actually did put in the concrete pad for the observatory, so it's all there. Well, anyway, after getting there, I realized, I'm having trouble breathing. I couldn't breathe. It was really hard to breathe. Hey, Laura Newbert. Really hard to breathe. And so I ended up just struggling to breathe and for several days, and I finally was able to breathe after that. But I don't know whether it was really COVID or not, but it might have been. But luckily it was it was as short-lived as possible, I guess. But they are all SARS-related viruses, and Terry Groff is right. There's more than one kind of corona, essentially. Yeah, So I just think that it was kind of cool. This is the live moon, by the way. This isn't the photo. I mean, we're looking at the live moon. You can tell because when we zoom in, you can see the seething atmosphere, the unsteady, turbulent atmosphere. Usually this is what the sun looks like when you look at the sun. It looks like this because it's you're looking straight into the hottest part of the atmosphere that is local to you. So let's see here. Let's take a photo. And by the way, again, I'll just run through this again just for this. All right. So what we're doing here is this is our live view in the middle right there. Okay, this is the telescope control system. We have telescope north, south, east, and west. We have telescope computer. We have focus here. And we have the filter wheel here. We have a 5-position wheel there. So it looks like a rotary gun almost. And it rotates different filter in over and over. We're looking right now, we're in narrowband 2. So we're in filter number 2, the slot number 2. If I go back, we go to narrowband number 1. This is a filter that shows a different type of view. We're looking at different swaths through the spectrum of the lunar light coming to us. Then this is 2, all right, and then there's 3, 4, and 5. Well, now, so that's the telescope control system there. Down below, that's the me control. That's me. Okay, there's no picture for Daryl, but he's threatening that he might actually put one up and allow us to have a picture of him, or maybe even a live image of him. Yeah, Daryl, you've said that before. Am I wrong?
I did the other night, and it broke your monitor.
Well, I got a new monitor. It's okay. It didn't break the monitor too badly. After the monitor recovered, it was fine.
Someday.
No worries. And after that, this is our live view, as I said. There's today's title, or what our stream is. We have that up here. Okay. And then this is the camera control cluster over here. This is the STLS logo. This is the camera button to take a picture. This is the exposure, 1/8 of a second. And this is the ISO. These are the two locations you care about most right here. All right, 80 ISO. We can actually go to 50 right now because this is a bright object, and we can just increase our exposure just a little. And you see what it did there. So we take a picture. Okay. Oh, and this is the live observatory view down here. This is the view into the observatory. This object that you see right, let me show you. This object right here, if you look at on that lower right picture of my cursor's in there, see it in the black? Okay, this is a bar that goes to the telescope, and this is a big round foam pad, which I've made especially because it's actually going to close over the opening of the telescope automatically. So the telescope opens and closes automatically, taking off the lens cap basically is what it's doing. And when it gets out to Arizona, it's gonna be modified to manage taking off the lens caps of several telescopes that are all mounted on this unit that you see here. Everything you see in this image here is going to Arizona, okay, except for the dome. The dome is staying here and getting disassembled, and we're going to make this into a roll-off roof observatory as well. And we have another telescope for this Skytour Livestream East, which is what this is here, and Skytour Livestream West is the one that we're building in Arizona. Yeah. Yes, I know. Huh says, I'll be waiting for you on the dark side of the moon. That is no dark side of the moon, really. As a matter of fact, it's all dark. What's that from, guys? What's that from? Yeah.
Wish you were here.
Yeah, I know. I have a lot of active air, Keith, you betcha. Look at that, huh? The moon is pulsating. Hey, wouldn't it be great if the moon just like exploded? Boom! We'd have about 4 hours, 5 hours, depending on the speed of ejection. 5 hours before that stuff started entering the atmosphere of the Earth. Yeah. Interesting thing. The Chicxulub impact that killed the dinosaurs 65 million years ago. That impact made a crater smaller than it was a little bigger than Plato. Okay. Maybe a little bigger than Copernicus, the actual crater. On the Earth. And this is only 2,000 plus, just slightly over 2,000 miles across. Earth is 8,000. But it made such a tiny little impact scar on the planet. Yet it had far-reaching consequences with extinctions all over the world. How could that possibly happen? Well, it happens because of the fact that when that stuff was thrown up into the atmosphere from the initial impact, it was molten and went up into the atmosphere, and that stuff had to come back down. And it came back down all over the place, not just in this little area where the Yucatan Peninsula was, everywhere. And it was still hot. It was very hot, okay? And when that stuff re-entered the Earth's atmosphere, it began heating up the air that it was contacting. And imagine this massive blanket of ejected material, all molten, all 3,000 plus degrees, re-entering the atmosphere over thousands of miles. It stays hot, and it made the atmosphere extremely hot. The temperature rose up immediately on the ground. The temperature got up to several hundred degrees on the planet surface in various areas on the planet. It actually was a kill zone. On the far side of the Earth, there were animals that survived the initial impact, but the dust pall, the dust that was thrown up into the atmosphere that made its way around the Earth in the stratosphere, blocked light. It turned day into night for many, many weeks, long enough to kill plants, which then killed the herbivores, those plant eaters, which then killed the carnivores, who were the eaters of the plant eaters, right? So the domino effect took place, and thus the end of the dinosaurs loomed with the impact of a relatively large but destructive asteroid strike off the Yucatan. And it was an ocean strike, actually. It wasn't a land strike, per se. So it's kind of amazing how to a thing like to a thing like an asteroid, it doesn't much matter, does it? Right? Ocean or water, it's through the water in no time. So it gets to the bottom of the ocean floor. Hey, look who's here. I see Amanda.
Yep, Amanda's here.
Amanda, did you want to join us? I guess I lied. I said that you couldn't join us because you were doing your other thing, and apparently that's not true. You are here. So let me know if you wish to join. If you want to join, I can certainly do that. So anyway, on the Earth, it got really, really, really hot, and the rise in temperature, it contributed to killing off a lot of the animals. Now, just imagine what would happen if that happened now. I can barely hear Daryl. Okay, she says she can't. Okay, she can join.
Can you hear me now? I wasn't saying anything. Do I sound okay?
Yeah, I don't know why you got so faint all of a sudden.
Is that any better?
No, I don't think so.
My settings are where they were.
Huh. Okay, I don't know. All right, let me.
Is that any better?
No.
Testing. 1, 2, 3. Testing.
Again.
The quick red fox jumped over the lazy brown dog.
Okay, well, let's try to run with that for a minute. See if that works, because that's a little better.
Okay, I'm looking at your sound level for me.
Yep.
Wonder what changed.
I don't know. I played with the mix at this end to see if that would help, and apparently it did. And Amanda, you're being added right now. Okay, so we will hear from Amanda, and here she is. Amanda Curran.
Hello.
Hi, Amanda.
Hi, Daryl.
And
Hi, Mark.
see,
Hi,
look at-
chat.
And
What's going
Daryl,
on?
as soon as Amanda joined, Daryl's mic went back to normal.
Oh. Maybe it was just me. Other people in chat are saying that they can hear him fine, so... But Mark sounded fine. It was Daryl that was low, so...
Yeah, he was low to me too.
Oh, okay.
But I think he's fine now.
Yeah.
I'm just excited because Amanda's here.
There you go.
Well, there you are. Yeah, I'm going to take a picture. Yeah, we looked at Mars already, Amanda, but the atmosphere is not quite still enough. You can see that the moon is even a little bit tough to focus on right now because it's got a kind of a bad sky right now. The turbulence of the atmosphere is somewhat bad right now, you know, as Keith, in fact, from P&K Space Imaging pointed out. Hey, Daniel Whitaker. So, don't know. Hey, Animesh. Animesh Kasabi is here. Hey there, how are you? Feel free to, you know, if you haven't joined SkyTour Livestream, please do. It's a wonderful place to just hang out and look at the night sky. We're looking at the moon right now as a last thing. We were looking at Mars earlier, and we looked at the double cluster, which is really pretty.
Nice.
Yeah. Let me see if I can...
Looks to me almost... Is that a live view?
No, it's not. This is a photo. I can... We'll get the live view right now, though. Here's the live view coming up. Here we are. That's our live view. And if we magnify it, you can see it's like looking at the surface of the sun. It's boiling away.
Yeah.
If we head a little bit toward the west, we head toward that edge, we can see we'll go to the lunar highlands down the south here. You can see how that looks. It's really kind of turbulent here right now. Yep.
Oh, bummer.
Oh, you're welcome, Animesh. I'm okay with names.
Reminded me of Yummy Mush.
Yummy Mush?
Yeah.
I don't know Yummy Mush.
No, he's a gamer.
Oh.
On
Gotcha.
YouTube. Yeah.
So this is our magnified view here, so you can see we got a lot of stuff here.
That's crazy. It's crazy to think how much detail you're picking up from your front yard.
Yeah, and it's actually relatively poor considering that we have the turbulence of the atmosphere to deal with right now. That's okay. Not a problem. It's okay. We're all enjoying it anyway. You know, we have 50 people watching and people are happy. We looked at Mars for a while. It was really cool.
Very cool.
We actually have 65 people watching tonight. That's fantastic.
Oh, wonderful.
Yeah, I'm thinking, oops, oh, that's my program. That's more like it. So that was my observatory control program, everyone. I just had that up there.
See, I bet most of the people in here
Yeah.
probably have some kind of astronomy as a hobby or something. Because I don't know if everybody is most people, if there was a meteor shower or something like that,
Yeah.
most people would hear about it in the news.
Sure.
But Mars being the closest to Earth, it will be for approximately 15 years. I don't think that gets as big of coverage.
I know.
I mean, it might get a mention, but I think people must know about this on their own. Look into this and know about this on their own, rather than
I
heard
think
it
so.
and want to check it out. I think people are specifically looking for this.
Maybe so. So what we should do is go back to Mars and check it out again, Daryl.
Do you agree with that? I mean, maybe
Yeah, no.
Well,
people were
absolutely,
just
I
lucky
agree.
and find it, or
Yeah. Well, I mentioned earlier before you were here, Amanda, I got an email from my brother tonight. He heard about somewhere on the news that Mars is at its closest tonight. He tried looking at it with binoculars and couldn't see much or anything really except the blob of the planet. So
Yep.
I suggested he come here. I don't know if he showed up or not. If he did, he was lurking.
Okay. Well, I'm gonna head to Mars right now again. Let's go back and
Yeah.
watch the moon vanish right away here. Yahoo!
Who knows? We may get lucky.
Yeah, maybe. And here you can see in the telescope view down here, you can see the telescope moving. I can imagine I'm gonna have to move the dome though. So you and Amanda can hold down the fort while I go move the dome, okay?
Sure.
All right. I never motorized the dome, guys, because I wasn't planning on keeping the dome for a long period of time. But
Now they're complaining about your audio, Mark.
my audio?
Carol is.
My
yeah.
audio?
Was
Uh-oh.
someone else mentioned that earlier too?
Uh-oh. Oh,
Way back.
I can see. Maybe this is better. Maybe this is better. Yes.
Isabella. Oh, and I didn't say hi to Isabella. I'm sorry. Hi, Isabella.
We have another Amanda in the room too.
I saw that. And she knows the exact date we'll see Mars at its closest. June 10th, 2020. I assume that's June 10th and not October 6th, but
Okay. Well, I want to thank you, folks.
I think she is wherever she's at. They do day, month, year. because it is October 6th.
Okay, there you go.
And that's today.
I shouldn't be low anymore. I should be, I should be at a good volume right now.
Yeah, they all agree. It's better.
Okay. All right, here's what I'm going to do now. This is Mars, and if you notice, we are... And I focused it on the moon, so we're going to see if that focus holds for Mars. That's how big Mars is in my scope. It doesn't look very big, does it? Well, just wait a second, because I'm going to do something magical. First, we're going to go to narrowband 1, okay, and then we're going to increase the exposure a little bit. 80 worked before, Daryl and I found, and we're going to go up to 1/4 of a second, and we'll take a picture. And let's go and look at Mars, see what it looks like. Yeah, I mean, we can see surface detail, but we're still suffering. Hang on. Why is that? This is narrowband 1, right? Okay. Let's try this. Let's drop it down to... I was doing 1/8 of a second before. Let's try that. Okay, that doesn't look too good to me. Now, of course, I could actually... It looks like I have a piece of the dome in the way. I think I have an edge of the dome in the way. So I'm going to go out and verify and or move that, okay?
Okay.
All right, I shall be right back. That looks pretty good, though. I'll be right back.
And only because you mentioned October, probably irrelevant, but is Mars in Libra?
Mars is in Eastern Pisces.
I want to ask it, but I don't want to sound dumb, but I'm tired, so hopefully you'll forgive me. Do you know, will it be in Pisces again in 15 years? Or will things have moved by then that it would be a different symbol? Or is there any way we can tell, or is it always exact? In October, Mars will be in Pisces for this opposition. Or not opposition.
Yes, opposition.
Oh, it is? Okay. Do you know that? Can we know that, or?
Give me a minute. I'll go look at. Let's see.
Okay, so you can know. You just personally don't know offhand. Then is that it?
Well, no, not offhand.
But you can, like, it can be figured out, right? Obviously.
You want to know where Mars is at opposition in the year 2035? Is that what you're saying?
Yes.
Oh,
I'm
no.
just wondering, cause like.
Well, every opposition is different. Mars jumps jumps a zodiac sign or two for every opposition. Like this one is in Pisces. The next one might be. I don't know offhand, but over.
Would it be
in
the
Taurus.
next one over, or would it be several, or?
It will jump 1 or 2. I want to say from opposition to opposition. Successive oppositions tend to move from west to east across the sky. Every time, it slowly advances across the sky for each opposition. I don't know offhand. I'm going to try something here. I am at. I wish I could share screens with you.
What's the matter?
I'm at Heavens Above.
Oh, okay.
And no.
Well, I'll tell you what we're trying to figure out, Mark. And it doesn't. I don't know exactly where I'm going with this. It's just kind of something that came into my head. When Daryl mentioned that Mars was in well, I don't know, maybe you weren't here for it. He said that Mars was in Pisces right now. And I was wondering, because like when I read that date wrong, thinking either June or October, and Daryl said it would be October. So if Mars's opposition is always in October, is it also always in Pisces? I was guessing Libra because
Well,
of his timeline for no.
Yeah. Golly, I want to say the last opposition was in Aquarius, 2018, and the one before that, the first perihelic opposition I ever saw was in Scorpius, and that was back in the 80s, mid 80s, 85 or 86, I want to say.
Because Anahata is saying that Mars will be in Pisces in June of 2035. Okay, so, but I was wondering about October, so obviously it's going to be somewhere else. So, okay, you said, oh, no, never mind.
Well, here's Pisces.
Well, why was there one 2 years ago and now there's not going to be another one for 15?
Well, there will be another one in another 26 months. Oppositions happen every 26 months, roughly.
It'll just never be this close again for another 15 years. Oh, okay, gotcha.
This is a so-called perihelic opposition when Mars is closest to the Sun and Earth is on its way out, so we're relatively close in our two orbits.
Okay.
This will be the last perihelic opposition for some years. Oh, let's see. March 2035, blah, blah.
Sorry, I should know this.
It will be in Capricornus in March 2035. It will be in Aquarius on May the 24th. Scanning. I'm at the ALPO website, Association of Lunar and Planetary Observers.
You'll notice Mars just disappeared. That's because it's going in and out of clouds. There are clouds here now. They have found me.
I wonder if Mars is going to be in Taurus in 2 years.
Well, that's what I was wondering.
Or not Taurus, Aries.
Well, Aries is the one next to Pisces.
Yeah, but didn't you say it was in Aquarius 2 years ago?
Yes. If I remember correctly, it was in Aquarius 2 years ago.
And that's right before Pisces. So it would only be a sign every 2 years? Does that sound right? No?
Well,
I don't know what I'm talking about. I'm probably wrong. Sorry, chat. Are you glad I showed up?
Yes, we are, actually.
If oppositions happen 26 months apart, that is 2 years and 2 months, so it would advance 2 signs of the zodiac in those 2 months. Does that make sense? So yes, I would sort of expect it to be in Taurus at the next opposition. Does that make sense?
Tune in to find out. Hit that bell and subscribe.
I'm looking. Bear with me. Oh goodness.
Ooh, look at that, Daryl. This shot actually.
I'm sorry.
Look at this shot. This is Syrtis Major here.
Yeah.
And it's
has
advanced
moved quite a bit
across from the planet. We looked at it when the first there was here, and it's rotated this way because, of course, Mars is rotating, counterclockwise as seen from the North Pole. That's basically this way, kind of at a slight angle because the South Pole of Mars is right down here. You can barely see the cap. Looks pretty though. Yeah, and Tara's right. The clouds. Hey, Mr. Stony Loney, how are you? Thank you for joining us here.
In the year 2035, Mars will appear to move backwards when it's in retrograde, close to opposition. Pisces and Aquarius.
Yeah.
So it'll be up in the same general area of sky here, but a little farther west. It will move from Pisces back into Aquarius.
Okay, well.
Interesting.
I have high altitude clouds moving in, so unfortunately, it's going to be catch as catch can for the remainder of this stream, I think, for today. But it was beautiful earlier. We had a nice run earlier.
We did.
Yeah. No, Daryl's not asking a question. He's agreeing. We did.
Mm-hmm. Oh.
Yes, you're right, Isabella. It is rotating. You can clearly see when it's visible, but right now Mars is behind clouds, unfortunately.
I feel bad.
Yeah.
Cloud showed up when I did.
That's okay. Oh, it just came back for a moment. Oh, there it went away. It's going away. Okay, it's back. Oh, no, no. Oh, come back. Move it. Get away from me. Never come back. That's okay. You know what we'll do? Let's go take a look at the previous images, shall we? Okay, so we took a number of images throughout the course of the night of Mars. And they were really, really pretty. So here's one there. Of course, we took some shots of the moon as well. But there we go. Give you an idea of what it looked like, Amanda. Check it out.
Wow.
Yes, there's Mars there. Let me give you full screen so you can see it. Okay. Now, when you look at Mars at that point, okay, you look here, you can actually see this area right here. This is Syrtis Major here. It's a very dark area on Mars, and then there's a little tiny south polar cap right here, like about that 7 o'clock zone, right about there. Okay. So we actually get quite a lot of detail here on Mars. It's really pretty. So it's done good for us. Oh, hi there, Isaac. Thanks for
I was
coming.
just explaining that, yeah.
Okay, cool. Thank you. Yeah, very good. Amanda's correct. We're using a filter that actually shows Mars in an incorrect color, but it's actually a colors that actually show Mars detail better. Actually, I'll show you what's going on. And here is the telescope control system. As I said, we're using filter 1. If I go to filter 2, and it's best to do this while we're actually in the live view. Mars seems to have disappeared from our live view.
Excuse me for a moment.
All right.
Sure.
Yeah,
Ronald was asking if the final cut was going to be purple too, and yeah, unfortunately he has to change the color, but it's to bring out the detail. I actually asked him the same thing.
Yep.
After our last stream that I was with him. I said, can you grab the detail with these filters and then change it back red? But Mars, the real color would just be too dark to bring out all those details. So
yeah.
Unfortunately, it's kind of a trade-off. I would rather see it red, but get it like that detail is incredible. So
Yeah,
I think people want to see that too.
That's true. And what I was going to do was I was going to show folks what it looks like in the regular color.
Yay.
So to do that, we have to just pop back here, and obviously there's no filter now. This is a straight through view, so I have to reduce the exposure. Okay, and it won't be focused because the filters cause you to have to focus it differently. But let me just take a picture. Okay, that's the color of Mars.
Wow.
That's the actual color of Mars. It's not the focus of Mars, it's the color of Mars. Okay, and so as I've said before, it's that ruddy brown color is due to the oxygen in the Martian atmosphere that's ripped apart from water molecules that had been in the atmosphere for millions and billions of years over time. When Mars lost its magnetic field, the oxygen was separated from the water molecules by the ultraviolet radiation of the sun. The hydrogen was lost to space, and the oxygen went down into the ground where it bonded with all of the iron-based compounds in the ground, because oxygen is a lovely oxidizer and catalyzer, and So the oxygen actually bound up with the iron and made various types of what's called hematite on Mars. So basically, Mars rusted, and that's what we're seeing. That's why it's the reddish brown color. So it's pretty cool. Corrales Flores, hi there. Welcome. Welcome, thank you. You're in La Paz, Mexico. Bueno. Welcome to SkyTour Livestream. This is SkyTour Livestream East. SkyTour Livestream West will be opening hopefully within the month in Arizona in the dark desert sky. We poured the pad some months ago, and we're getting a contractor to actually put this all together for us soon. Hey Crash, how are you? Crash or Conquer? I opt for Conquer, thank you. Conquer this view. Okay.
Well, Crush wants to know where it is in the sky, but we need to know where they are, I guess. Other than just up, you know?
No, I can actually show that. That's a good question, Crash. And let's go give you your answer. So,
I missed the question. What was it?
Where is Mars in the sky? Okay.
It's in eastern Pisces.
Okay, right now, if you look, it's depending on where you are on the planet, it's going to be yes, it's going to be in eastern Pisces, which is Pisces, of course, are the fishes. And if we were to look at the picture for the mythology, okay, there's the fish. Okay, and it's
North Carolina.
Oh, North Carolina? Okay, then in North Carolina, Mars is going to be a little bit higher in your sky than it is here.
It'll still be in the same constellation.
It will be indeed, but it's going to just be higher in your physical sky because it's going to your horizon is not my horizon. You actually are going to see more toward the south. You'll be seeing more stuff down here. So Mars will be a little bit higher in your sky by the difference in our latitude. My latitude is 41.5 degrees north. And down in your South Carolina, you've got to be like 35, 30 something down there. And so you'll get that much more height in the sky for Mars. And it'll still be in your southeastern sky right now. And if we actually get rid of our equatorial grid and bring up our regular grid here, okay, then for us, Mars is about 50 degrees up in the sky, a little bit less. You're going to have Mars being more than 60 degrees up in your sky from your southern view. Okay, so it's going to be a little better looking down there than it is here. So all right, let me go back to...
So now we have other people chiming in to see where they can see it from. Pennsylvania would be similar to you, right, Mark? In Connecticut?
That is correct. It would be. It's just that it might be a little more... If you're in Pennsylvania, if you're in western Pennsylvania, then Mars is still going to appear a little bit lower in your sky, right? And if you're in eastern Pennsylvania, it'll be higher like it is here.
Thinks I don't know where all the states are. And
that's not because
I guess
know her
everyone
Canada,
in the States
guys.
and Canada can see it, yes?
Yeah.
Who can't? What, Australia?
No, Australia can see it too.
Yeah.
Just tomorrow afternoon or yesterday afternoon?
When it's dark.
Daryl's gotten low again.
I'm sorry. Hello?
Yeah.
I didn't change anything.
I know. I don't know what's going on there.
Anyway, when it's dark in Australia, they'll be able to see it. It'll be low in their northern sky. Rather low in their northern sky.
They're northern, okay.
Yeah. When we look up, no matter where you are, it's going to be in the constellation Pisces.
Yeah.
And the zodiac should be visible from Australia as well, but it's going to be to the opposite from us. It's fairly high in the northern sky for us. It's going to be fairly low in the southern sky for them. I would think.
Like, I mean,
Yeah.
I sounded dumb asking that question. Like, yeah, of course they're going to be able to see Mars, but like, what, like, do you know down to like the hour when it's actually the closest to Earth? Like, are we catching it now, or is it going to be in a few hours when Australia can see it? You know what I mean?
It's the 7th already in Australia.
Well, it's
Yeah.
the 7th for me already in Canada.
Yeah, well, I'd have to go look it up. There was a time, a particular time when Mars was actually closest to Earth. Uh, a few hours is going to make no difference. A few days is going to make no difference.
Okay.
Like I said earlier, Mars is actually in opposition on the 13th, a week from now.
Oh.
But just to look at it in the telescope, you won't be able to tell any difference.
Yeah,
You won't be able to tell any difference a month from either side of opposition.
Yeah, he's definitely right about that. You won't see it.
Could you put Stellarium back up for a minute, Mark?
Yeah, just a minute. Let me pull out of here. Okay, let's do this and do that. Let me get rid of observatory view. We don't need it.
See,
Okay.
and I think it's hard for people, like, if they don't, like me, I mean, I can never see constellations. Everything just looks like stars. I can never see the shapes or anything. So, like, how would you explain to me where Mars is as opposed to, like, another really bright star if I couldn't see the color?
If I did it on a day-to-day basis, I would give you that information based on looking at the moon and a discussion of the ecliptic, because Uranus is actually right near Mars tonight.
Can you scroll back out a little bit and put the constellations back in? The mythological figures? Okay, you see Pisces. Pisces is two fish that are tied together by a ribbon or a cord around their tails.
Okay.
Can you see that?
Yeah.
And Pisces is not a prominent constellation. What a lot of people look for over there in the western fish toward the right edge, you see the head of the fish there. That's called the circlet of Pisces. That's probably about as prominent as anything is in the constellation.
Yeah, that's about it.
It's easier to tell if you know where Aquarius is, just farther to the west. Pisces sits between Aquarius and Aries.
Okay, I hope that's helping people out there. It is. I mean, for people that really want to go outside and see this while they have the chance, I want to give them as much information. Other than going state by state, you know, I
right.
Well, how to...
just to say, I mean, the farther east you are, the higher Mars is going to appear in your sky. If you go out now and look up in the southeast, it is unmistakable. It is by far the brightest thing in the sky up in that part. If you're farther west, it's going to be somewhat lower.
Yep.
But, you know, generally if you look southeast, right now, see Mars is a little bit west of southeast. It's sort of south-southeast or getting there.
Yeah.
If you were here in Colorado, well, it's going to be 2 hours farther west or earlier. So it's going to be a little bit farther to the east. But just in general, if you go out and you look up in the southeast, it's unmistakable. The brightest thing in the sky up there at that time is going to be Mars.
And there it is.
And it'll have a reddish cast to it.
This is it without any additional constellation lines or anything else. Like you see it in the sky almost. Okay. That's what you're going to look for. And it's generally in the south-southeast. As the night wears on, it'll head more toward the south. And as far as its elevation... Okay, we can look at the elevation of it. You can see that this is a zenith view. So looking straight up, we're seeing directly overhead. Okay, so it's like putting a bowl over us all, and looking at where we fit in looking out from here in the bowl. We're not trying to look at the Earth's coordinates or anything. We're just looking at our local bowl over our head. And if you made if 0 was the horizon, Mars right now is almost 50 degrees up in the sky here in Connecticut, right? The farther south you go, the higher Mars will appear in the sky. Okay.
Yeah, and Mars will be at its highest at local midnight when it transits the meridian, at least next week when it's at opposition. It'll be a little bit late tonight. Uh, that will be at local midnight, but what that means if you're on daylight savings time, it's going to be about 1 a.m. your time, depending on where you are in your time zone,
Yeah.
is when Mars will be due south, and that's when it will be highest in the sky.
Yep.
And will you see reddish hue to it with the naked eye?
Oh yeah.
Yes.
Yeah?
Oh
Okay.
yeah. Oh yeah.
Awesome.
Without a doubt, you can't miss it.
When Mars rises, actually it looks redder. Some of that may be because we've had so much haze from the forest fires here. But when it rises, it'll look very red. As it gets higher, it will tend to brighten, and it'll tend to wash out the red somewhat. But it will still be a reddish color.
Very
And
nice.
it's absolutely unmistakable. That's the fourth brightest thing in the sky right now after the sun, the moon, and the planet Venus.
Yeah.
There's no mistaking it.
Yeah,
Wonderful.
you definitely see it. So if you want to just look at Mars with your naked eye, take a little walk outside if it's clear. And again, if you're in the east, over where I am in Connecticut or on the east coast, it's going to be southeast, and it'll be varying elevations depending on where you are in the United States. It'll be lower in the sky if you're out west. So it'll be lower and lower and lower until maybe it hasn't even risen yet, depending on how far you go. But it's
anywhere in the U.S. it should have risen by now.
Of course,
As I said earlier, Mars a few nights ago, Mars was rising before 7:30 at night now.
Yeah, but we got people
And-
that are listening
And that'll
from
be
all over
pretty
the
much
world
the same
now.
for everybody, whatever your local time is.
Yep. But it's hard
I
to-
don't know if this was mentioned earlier. Mac wants to know when the last day we'll be able to see Mars with the naked eye is this month.
Oh, we'll be able to see Mars naked eye for months yet.
Oh, very good.
It's got a ways to go.
After opposition, Mars is going to be. I've used the analogy many times before that we're on the inside lane of the big round superhighway going around the sun, and Mars is in the right-hand lane to our outside. Well, we are passing Mars a week from today, on the 13th, either 6 or 7 days from now, depending on where you are right now. We will pass Mars on the 13th. And Mars will be doing its best to keep up with us, but it will slowly be losing ground night by night and falling farther to the west. And Mars is sort of unique in this sense for one of the superior planets, because it's the closest orbit to ours. Mars will hang in there for months and months and months. It'll start moving again in regular motion, moving west-east across the sky every night. So it's going to be like we pass the guy and we look in our rearview mirror, and Mars is still there, but it is slowly falling behind us night by night. But it's going to be there for months yet.
I love that analogy. That is so relatable for everybody.
Yeah.
Yeah.
And you'll see where Mars has been stuck in Pisces for a few months now. Well, Mars is presently moving backwards in Pisces because as we are passing it, we're seeing it shift due to parallax. Mars will Mars will start moving in direct motion again, west to east, and we will see it once again start racing across constellations as it tries to keep up with us. It'll move from Pisces into Aries and Aries into Taurus, and I'd have to go look it up again to just tell you how far in the future it will be before we see Mars disappear into the sunset. But it's going to be quite a few months from now.
Yeah, it won't be as big, but it's going to slowly get smaller over time. But that's not going to be as big a deal because we're still going to be able to see Mars for quite some time. It's just that tonight's a magical night because essentially tonight is the closest approach to Mars that the Earth will have for this time around. And we have a closest approach every year basically, every couple of years. So it just depends on the timing to see when Mars is going to be the largest. One of the things that is a misnomer is that they say Mars is going to be as big as the moon in the sky. It's an internet thing that goes around, and whoever started it is either woefully inadequate in terms of their astronomy knowledge, or they're just conniving little schemers, because the fact of the matter is Mars will never be the size of the moon in our sky. Mars would never collide with Earth. Mars would never be that big. I think that people talk about the brightness of Mars and they confuse it with the size of Mars. They say Mars is going to be, 4 times brighter than it was at this point in time, or 3 times brighter. And they'll end up saying, that means it's going to be 3 times closer, and then that gets confused, and that becomes an internet thing. And before you know it, there's all kinds of bad information.
How that happened.
What's that?
I said I can tell you exactly how that happened. You can consider that a hoax nowadays, but
Yes.
It all started during the 2003 apparition of Mars, when Mars was at its closest in thousands of years.
Yeah.
The original statement was, if you look at Mars through a telescope at, I think it was 71 power magnification, Mars would look the same size as the moon to the naked eye. That is, its apparent diameter would be 30 minutes in the eyepiece. But even then, Mars is only, 23 arcseconds across or something.
Yes.
But Mars, during the 2003 opposition, at a power of 71x, would look the same size as the moon does to the naked eye. If Mars came that close, then you should be able to see lots of detail, and you could. Except that 2003 was a year they had the planet-wide dust storm, and we couldn't see squat on Mars.
That's right.
Somebody read that, and they misinterpreted it, or they purposely skewed it, and they said, oh golly, 2003, Mars is going to look as big as the moon.
Yeah. They
And
left
that
out
just
the
plain
rest of
wasn't.
the, they left out
that
the
just
rest
plain
of the
wasn't true.
sentence.
Excuse me?
They left out the rest of the sentence.
Right. Well, they, for whatever reason, they misinterpreted it, or they purposely misconstrued it to say that Mars was going to look as big as the moon to the naked eye.
Yep.
Now, you could do a little over-the-thumb math. I did it back in the day, and I don't know if I can think of it now because it's getting late and I'm tired. Mars was, oh golly, I'm not even going to try. It's too late for that. But it talks about how many times farther away Mars actually was in 2003 as compared to the moon.
Yeah. Many millions of miles more.
Well, let's see. If Mars is twice the diameter of the moon, but it takes 71 power to make it look the same size, what would it be? 71 times 2? It'd be 142 times farther away than Mars, I guess, in 2003. Mm-hmm. Does that make sense?
Maybe. I'm not really thinking about that. I'm letting you manage that because I'm looking at the chat and seeing who knows here. I see Kalyan Shakrala. How you doing? Mars looks blurry because we have some light clouds up overhead right now. It always looks a little more blurry because the sky is, we're looking at it through air, and that makes it really hard to see. That's why we take a lot of photos of it, because by taking lots of photos of it, we'll be able to catch it at its best. And like right now, I have to take up to a 2-second photo. Okay, right now, see, I went back to 2 seconds. See how it's going in and out? Okay, see that? It's going in and out. It shows up and then it's gone, Then it looks bright and then it gets dim. That's because there's clouds passing in front of it. We had a cloud-free night earlier and it looked pretty good. And usually when I take photos of it, I don't have to, I literally take photos of it when we're at like, see how it's fading and coming back, fading, coming back. So here I am. You can see that now. Yeah, we've got clouds. I have to be careful because I got to make sure that the telescope doesn't get covered up in dew. So what we will do, no pun intended, is we will say goodnight for tonight. Just take one more quickie shot here so we can actually show what's going on. See that? We should be able to see clouds on, not clouds, but the detail on Mars. And right now we can't. We could earlier tonight. You know, when we looked at Mars earlier.
We got some great views earlier.
Oh, we sure did. And I'll go back to just a couple of those. Okay, this was a different filter. Let's see here. About this guy? Maybe this. Let's see. Yeah, look at that. You could definitely see some detail on the surface of Mars there. Lots of detail. Maybe not so much as this one, perhaps. But you could clearly see we were able to... We brought up a nice Mars map here. And we could point out some of the detail showing up on the surface. And where we were was... We've been seeing this area of Mars go by. Syrtis Major, Terra Terrena, and Hesperia here. These three areas were going by. They're the ones that are moving right more on Mars as we look at it. Really pretty.
Well, now you're breaking up on me, Mark.
I am?
Yeah.
Oh. All right. Well, let's see if it's related to voluminous music. Maybe it is. But this is the area of Mars that we were looking at right here. We're looking at this area of Mars tonight. That's what's moving across the view of Mars, the globe. Okay, we could see Hellas Planitia here. And it's down below the dark spot here. And on our imagery of Mars, okay, we can see... Here is Syrtis Major here. We have Hellas Planitia down here, and here's that other area here with Hesperia and Terra Terrena here. And up top we have the North Polar area here. It looks fuzzy here because it is actually fuzzy in a sense. There's actually a polar hood on Mars, which actually is an interesting haze area at the top that's very visible. We also have down here, you can just barely see the southern polar cap on Mars. So there's a lot of detail that we could see on Mars tonight. So this was one of our nicer views. But what I did, and just to show you that's how big it is in the telescope. Okay, so we're really cranking it in quite a good deal on Mars tonight. Okay. So what I did was I took video of Mars, so we're going to actually take all those separate frames and stack them. And we'll have a final stacked image, so it'll be pretty cool. You know. And Amanda's brain is no longer working.
No, just a lot of typos.
Oh.
We do have a question from Daniel asking about Mons Olympus. He wants to know if it ever sticks above the horizon of Mars. But I thought... Maybe that was on the moon, but I don't know anything, so...
No, he's right. It's on Mars. And
of course.
Olympus Mons, that used to be called Nix Olympia. Do you remember that, Daryl?
Yes.
Nix Olympia is what they used to call Olympus Mons. Well, it is a very tall mountain, one of the tallest in the solar system, rivaled only by one of the Venusian volcanoes. And actually, believe it or not, Mauna Loa on our planet in Hawaii, counting all the ocean floor. Well, if you say to stick up on the horizon, technically yes, but not as seen by any Earth-based telescopes. We'd have to see it, and I don't even know if the Hubble could pick that up. That's a good question, but I really doubt it. It's a very small feature for that planet as seen from the Earth?
It is the largest volcano in the solar system, I believe. I have heard it said, though, that if you were standing on Olympus Mons, you wouldn't even be able to tell you were standing on a mountain.
Yeah,
It is so big and the slope is so gradual.
It is a broad mountain. Yeah, it's like, yeah, and as I said, it is rivaled only by one of the Venusian volcanoes and our own. I think it's Mauna Loa here in Hawaii, in terms of altitude. Everest doesn't even enter into the picture. So it's really quite a big volcano on Mars.
Yeah. It should be visible if that face of the planet was facing us and we had ideal viewing conditions. It should be noticeable. It and the three Tharsis volcanoes.
Yeah, those are way over on the other side here. You can't really see those. They're going to be way out here.
Yeah.
Mark Wheatley, where did Mark Whatley actually plant his potatoes on Mars? Good question. I don't know where Whatley. We're talking about the show The Martian, I think. And he had to make potatoes. He had potatoes grow. It was really kind of a cool scene, that whole part of it. So I'm not sure, Rascally Rabbit, where he planted his potatoes, but that's a really fun trivia question. Do any of you know? Go ahead, Amanda.
Oh, no, I was going to ask. Mons is mountains.
Yes.
Is Mare, like, what they think water used to be? Like a place where, like, a lake or something would be?
Well, like on the moon, we know there was never any water on the moon. But Mare means sea. And it's usually the dark lava sea. Okay, the seas of dark lava on the moon. The darker lava being called a Maria or Mare.
So it confused me because I remember it was really fun. I don't know if I can remember them now, but when I went to that Mars thing, labeling the terrain on Mars, that was really cool. And I always mix them up. And Mons is mountain and Mare. Yeah, I thought it was like, I don't know, like didn't we land in the Sea of Tranquility?
Yes, we did.
And I don't know, like. What, like, I don't know. Yeah.
Well, don't stop talking. And I mean, you're asking a question, and don't say I don't know. I mean.
No, well, you explained it. It's the lava, but it's just funny that
No, but
seems like
your question is valid.
Used to be a lake there. Yeah. I'm just thinking out loud.
Yeah.
I shouldn't do it on air, but I do. So.
Oh no, nonsense. It's fine. You're just.
What other places? What other kind of words should we be aware of when talking about the terrain of? Are they different for a moon versus a planet? Like is the mountain of Mons on a moon as well as a planet, on Mars as well as our moon, or any Mons on Phobos or Deimos? Can we see them?
We have Mons on. I mean, they're just mountains. So we have them on Pluto. We have them on other places. So it's not like that's a terminology that's expressly just for a certain planet versus moon. It's just a generic term for a mountain. So it's okay. I mean, there'll be mountains out everywhere. And we just don't have them on Earth because we name our things. Because we're humans. We name everything. We're going to call that mountain Frank. Hey, that's Frank Mountain. And actually, just for you guys, a little trivia. SkyTour Livestream West is built in the shadow of Chuck's Mountain. There you go. Chuck's Mountain.
As long as he doesn't cast any shade on you.
Won't. But it's got saguaro cactus lining the top of it, so it's really kind of nice. Yeah, so anyway, our Mars view is kind of gone for the evening, guys. This is the last live view I just got. It's really not good. So I think we're going to call it tonight. But we did get some great views. I will process the imagery and get it up on the SkyTour Livestream Facebook site for all of you to see. Please feel free to join if you haven't. And if you haven't joined, I have to ask, why not? It's all free, you know? And make sure you hit the bell to get alerted when we go live. And we are the deep sky. P&K Space Imaging are the moon and planet guys. And Bill New York Skywatcher, he's the meteor and large swath skywatch sky guy. And if you want to see all three of our streams, you can also find them at astroimaginglive.com. All one word, astroimaginglive.com. And of course, we're on Facebook. You can look me up on Facebook, Mark D'Antonio. You can also look up my YouTube channel, which is SkyTour Livestream. You can also look up SkyTour Livestream in Facebook, which is an active group and a page which showcases all the things we photograph. And there's some spirited discussions up there too that people do. It's really nice. So we have a great family here with Daryl and Amanda and myself and all of you out there. And I wish to thank you guys for coming along for the ride tonight. We had a good time. Daryl, of course, a font of amazing knowledge. Thank you so much, Daryl, for joining us tonight.
Well, thanks for having me.
Of course, you're as I told you before, you're an astronomer's astronomer.
Oh,
it's true.
I'm a regular Cliff Clavin, as I always say.
You know, Normie, that's a little known fact. Yeah. Well,
thanks for having me all the same.
Of course. And Amanda.
And good night, everybody.
Thank you, Amanda, for joining us. Even though it was a little bit late.
Looks like everyone in chat had a great time tonight, so.
Yeah, we had a good time. Yeah, you guys, you know, everybody pulls it together, you know. SkyTour Livestream may have started with me, but you know what? It rapidly stopped being just me. It's not about me. Neither is SkyTour Radio. SkyTour Radio, 8 to 12, 8 to 10 Sunday nights on KGRAradio.com. We're a highly ranked show. We're number 3 or 4 in our time slot. And we reach a couple million people a month. And the show is really good. We had an hour show to begin with, and it was we were asked to go to 2 hours. And now we've been asked to go to video as well. So we're going to be...
And that's all because of you guys.
Well, yeah.
Well, Mark would be doing this anyway, but you guys want to see. You want to be part of it. You know, you want to ask questions and dream of what's out there. So.
Yeah, and you know what? We like very much... I'm just going to keep trying to take pictures while I'm here, right? Oh, Mars is gone again. Oh, here it comes. It's gone. We got all clouds. Forget it. So, you guys want to see stuff, and I, when I got my degree in astronomy, I decided I wasn't going to go and pursue further esoteric lines of investigation. You know why? Because I found myself asking questions, and I thought, people have questions out there. There's a lot of things people want to know. So, I think what I'm going to do, I thought, I'm going to take my astronomy knowledge down the outreach path. I want to bring this to everybody. And it took a number of years to get to where we are now. This telescope started life with my friend John Zach and I. We actually were going to take the telescope you saw in the dome here tonight. That telescope was going to be a remote observatory that my friend John and I were going to create. Now, John passed away, unfortunately, of an insidious cancer, and so we didn't get to do it. So the telescope sat untouched for probably 6 years, and then I ended up having my surgery, came back, and as therapy, I said I'm going to make an observatory. And Bill New York Skywatcher and Keith at P&K and Paul at P&K Space Imaging decided that I should probably stream. And they really didn't give me a choice. And I really didn't know if I wanted to do it. Because I didn't know if I had that kind of energy anymore. I rapidly discovered that I do. And it's all because of you guys. You know, you really made me realize that bringing astronomy to everybody is very, very satisfying. And so I'm really pleased at how this has turned out and where it's going. We're over 4,400 subscribers and counting. Keep it going. Keep it going. Oh, and you know what? I got to show you something. I haven't shown you guys yet this. I need to show you this. So I'm going to pull up big here for a minute, and I'm also going to go and get rid of this background doing this stuff to you that's making you crazy. Okay. Uh-oh. Now you see my ship. Now you can see I'm on a ship. Look, see my portholes. Yeah. Well, look.
Yeah, the views we're getting are from your Periscope, right?
Yeah, right. No. Here's what we got. Check it out. These are Sky Tour Livestream playing cards. On the front, okay, we have an object that we've taken a picture of in the observatory, and you can see its name. Okay, this here is the Needle Galaxy, one of Daryl's favorites. Okay.
NGC 4565.
You got it. And on the back is the
Very cool
Sky Tour Livestream. Is that backwards to all of you? It is, isn't it?
Yeah.
Yeah.
It is.
You know why it's backwards? Because the way the camera works, I had to reverse it. But it's okay. I think you get the picture. Then we have the things like the Merope Nebula in the Pleiades. All right, and I know that I got to just get it just the right angle. All right, so 9 of Spades is the Merope Nebula, and you know, if you're wondering what the Andromeda Galaxy is in here as well, but the Orion Nebula is the Ace of Clubs. Check it out. Oh, and every card has the name of the object on it. See? So
is the cat's eye in there?
No, actually the cat's eye is not in here.
What?
Yeah, Amanda. What? Say what? Where's my cat's eye? I like the cat's eye. Yeah, you do. Well, the bottom line is these are available to people that want to donate to Sky Tour Livestream to keep us going. This will go off to anyone who donates $30 or more. They're going to get a free. I said free, right? It's not free. You paid, right? Obviously, you donate, but a deck of playing cards to the people who donate $30. And we'll probably do it in a Patreon type scenario. I'm not. I don't like asking for money. I really don't. And to be honest, I don't want to. I'm gonna keep bringing this to you whether you donate or not. So that tells you. So I don't need anyone to actually do that. But I can't offer them without actually. I can't offer them without actually doing something about defraying that cost. If you want to buy them outright, well, then I can just give you a price to buy them outright, and you can just buy them. They're just cool. You know, there's 52 cards and 2 jokers. And the 2 jokers have 2 special images on each of them. And the others are all just images from Sky Tour Livestream from what we've taken. It's really cool cards. And I actually, I had a major playing card company actually put them together and did the custom work myself. I got all the custom cards done and built. And then, bam, they printed them. It was fantastic.
Nice.
And
they look beautiful. People are liking the looks of them.
They are very pretty. They're very nice. And I made sure that the printing was satisfactory. I bought 1 set to make sure it works. And boy, it does. I was amazed.
Good question. If someone donates, is this worldwide?
What do you mean worldwide?
If someone from a different country wants to buy a deck of cards, you'll send them anywhere?
It depends on, yes, I'm sure. I mean, the U.S. Post
Rio
Office,
de Janeiro specifically is being asked.
Oh, I don't doubt it. I think I can send to Rio. But the only thing is within the U.S. and overseas, there's shipping fees, shipping costs. Yeah. Now they're tiny. This how much can this little thing cost to ship? I'm not going to put it in a box this big. I'm going to put it in a box that barely fits this card. It's a tiny little packet. You could probably even go in a soft packet because that thing won't get destroyed. And they're shrink wrapped anyway, so you wouldn't have any problem with them. But man, it's just It's been the most fun putting together that deck of cards. I can't believe it. I don't even really play cards, but I like the concept. It's a cool concept.
Yeah.
Yeah.
All right.
Well, anyway, guys, thank you so much for coming. Again, this is where Mars is supposed to be. It's covered by clouds. I'm getting a little nervous. I have to do that. Thank you, Vera Lucia Campos. You're amazing. I want to thank you guys for coming out again. And I just wish to that it stays clear. I want it to be clear tomorrow and the night after and the night after. As the moon now gets smaller in phase every night, we get longer and longer times to look up in the sky. You know? So yes, I will talk to you guys the next clear night, which could be as soon as tomorrow if it is clear. Alright, guys? Stay safe. You guys have a good night. And when you go out, you make sure you keep looking up.
Night, everybody.
Oh,
I'm sorry.
it's okay. I want to change that line anyway, but I'm not thinking tonight, so.
Oh, it's all right.
I'll come up with something for next time. But everyone, have a great evening. Thank you for joining us.
Exactly.
Hope to see you next time.
That's a wonderful line. There's nothing wrong with that. Not at all. All right, guys. You have a good night. We'll see you again